So yeah, welcome everyone for day 2 of the Payara Micro training. So let's have a look what we are going to cover today. First of all, we are going to have a brief look on the exercise that I mentioned yesterday for those who had time to play with it. Had to just mention a few things because it was just a rather basic one. It's not that there was something really special or complicated, but it should get you started so to get some hands-on experience with Payara Micro. Then we talk about the microservices and Java in the cloud in general. Is that suited? What should you care for? What should you watch out for, etc.? And then we continue with the other MicroProfile specifications that we touched config already yesterday as probably the most important part, which is in MicroProfile, the config one. And then we look at the REST client. That's an extension of the JAX-RS one, so cover that a bit more in detail. And then we briefly go over the other MicroProfile specifications so that you know what their intent is and what you can expect from them. And if needed, then you can look up more about it and how you can use specific things. Then we will do a rather large block around data access. We do the standard Jakarta way first, and the JPA, Java Persistence API. And then we also cover, of course, a bit of MicroStream. As I mentioned, that's the sponsor, so they deserve their little block, and it is an interesting technology. So let's see if it can mean anything for you maybe in your next project. Later on this afternoon, we have the integration testing, which is also an important part of the entire process of creating something. And we look there how you can do that with Jakarta, which are the different opportunities what you have. It's not explicitly mentioned here, but there are also the different little blocks which are requested in previous trainings or yesterday, for instance, what are the different ways of creating Docker images for Payara Micro. There will be a example of using Hazelcast for clustering so that you can share data between several instances that are running, etc. So that will also be there. There is also an exercise for this afternoon, probably just going to mention it. And again, those people who who have the time, who are willing to play with it, they can play, of course, with it. And the solution is again in that GitHub repository. So yeah, first, maybe before we go to the review, is there any question about what we have covered yesterday? Is there any burning question, any burning topic that you say, I want to bring that up now at this point? I get someone who says no, but are there any other ones? Otherwise, is there anyone who played with the example? Do you have any feedback? Maybe just about it was too difficult, too easy. I was stuck with X, Y, or Z. Anything anything around it. Otherwise, I can just go over a few aspects, how I solved it. Again, there are several ways of solving these kind of examples, exercises.
Roland, I just have a maybe stupid question. Do I have to install Jakarta EE before I run anything?
No, Jakarta EE is
Okay.
included within your runtime. So
Okay.
Jakarta EE is available within Payara Micro, those web profile specifications, as we mentioned yesterday. In order to compile your application, then you need those API clauses. For instance, that add path annotation, that application. I'm going to show it this so that you have this application class available when you compile these annotations. For example, for that reason, you need then, of course, that web API, and that web API brings then in one dependencies with all those things. For instance, with CTI, you have those that inject, etc. But it is provided because, as I mentioned, the runtime has the API again, but also the actual implementation, and that implementation is then specific for your product, Payara Micro, Wildfly, Open Liberty, TomEE, whatever. So no, you don't add or install Jakarta EE into your runtime or into your application.
The point was I working with Eclipse, and yeah, at two libraries I had, it didn't compile your examples, your demos didn't compile, and I did the quick fix, and it just put it this missing libraries in the class path of Eclipse and not in the what doesn't run with Maven. This was my problem, and after then it works. I go to the demos, and this was what I did. And
yeah, okay. So probably Eclipse then added this dependency, this jar file, to your class path. That is, of course, needed. As I said, you need it at compile time. But as far or as good as I know Eclipse, you definitely should then mark that dependency should not be in your artifact, because otherwise it also includes that jar file within your war file, which is not the idea of having a API jar within your war file.
Okay. Oh, yeah.
Most of the time it will work. It might happen that there are class loading issues because you have done the same class twice on your class path at runtime, which means that sometimes it has loaded a class from one class loader, and then, for instance, add the interface, and then the implementation comes from another class loader. And although they are identical, because they are from different class loaders, the JVM says, well, this is not correct, and it fails. So that's one thing that you need to watch out, that you don't put that API into your var. It needs to be on the class path for compiling, that's for sure. In Maven, it is that's the reason why it's here provided. Normally, I think Eclipse IDE should be able to import this correctly, these types of POM files, but I stopped using Eclipse IDE for, 10, 12 years ago, so I don't have the latest info about it.
Okay, no problem. I will find a solution.
And it was not a silly question. It was a question of how do I get started with Payara Micro. There is also within Eclipse IDE IntelliJ and NetBeans VS Code also, you have also plugins to, for instance, run your application from within the IDE, etc., and those kind of things. As I mentioned yesterday, I'm not using that because at that point I also said maybe not everyone is using IntelliJ, and you see we have at least one Eclipse user, which is fine. So I'm not going to use much specific feature of the IDE because of that, for that reason. Any other comments? It's totally fine. It's also good feedback so that I and other people know what it is to get started as a newbie with a new framework, because I'm working with this already for more than 10 years and everything looks normal and easy for me, but that's of course not the case if you come from something completely different maybe. So yeah, if you start with as I showed, there was already, if you download from the GitHub, I'm going again to that GitHub repo. By the way, I pushed the latest changes, as I said there, that there were apparently missing. So there was few small things that I updated. So in this lab, you have then the advanced was with that security. So you had already some templates. So you have, for instance, that model already ready, so that you don't need to lose time as a figure of speech with it. Things that were required to create was those resources, those endpoints. You also needed this to create this class, which extends application. Mentioned that was mandatory. With that, where you define the part of the URL where your application lives. I used here now for this example just the slash. So it is not using any part of the URL for that, like yesterday, the example, like that API. And then we had here those resources. They are, some people call them those classes, but that's just a convention, call them resources, other call them controller. Again, that's what you like, what you prefer. And then, yeah, there are examples. This one uses the example with that query parameter. There are other with that path parameter to read some data. As I mentioned, we specify how they are returning, and there is some logic validation done. And here I made some initial effort to have some proper JSON replies. And so I created a class which is called error message. Best practice says that when you return an error message, it should be in JSON format, as I mentioned yesterday, but it should always contain some kind of code and some kind of message. That code is then actually the most important, so that if anyone says, oh, I had an issue, that they just can say, I received code XYZ123 as for that request, so that it is easier to retrieve back where that error happened, that error code, because that should be unique then, of course, within your code base, so that you can immediately pinpoint where the error came from. Message is, of course, to give the other party already an ID what went wrong, because yeah, XYZ123 does not say anything. But if it was like your minimum price was higher than your maximum price, then of course that makes a lot more sense. Like here, if the minimum price is higher than the maximum price, that you specified here for your search for products in a certain price range. Then you get that error message, and then that makes probably more sense also for the other side, that they already can fix that problem themselves. Also, I used the separation, try to split out your project already as much as possible. So I have here those resource classes, those controller classes, where there is already some basic validation, sometimes even not, then that's already immediately done in what's called the service layer, so the next layer. And that is then injected with CDI, so using then CDI beans. And this layer already should have no link to your view anymore. The rest endpoints are also considered as a kind of view, just as you have your UI. For instance, if you also have a JSF page, Java server faces. So this should be view independent in the sense that it just takes some data that the user posted, that the user requested, and some parameters like those minimum maximum prices, and that it fulfills those requests for the user. Not knowing how the result will be returned, so here you will always have something like a list of products which you returned. If you have an error, I'm not sure I have here an example. No, I don't have it here, but as I mentioned yesterday, you should have then those business exceptions that you throw, view independent, and then you handle them through that exception mapper. This is then pure for the business logic. Then there is a bit of logic here, as you see, and then the next layer is then your data storage. Where are the data located? Again, that's for me, it's another layer, so that, for example, you can change this layer. Actually, the example of this afternoon is that you adapt this layer to use microstream. So, but here it is just hard-coded in memory even, but not persistent in any way. You just have some lists which keeps your data. And whenever this object gets created by the system, that's at the first time, it just initializes it with a few data over and over again. So each time you start your application, you lost everything and you start over again. So the next thing is that you can do is then that this should be somehow persisted, JPA, which we will see later, or microstream, which is also covered later. Or any kind of other thing, NoSQL, Kafka streams. It's up to you to decide how you're going to store your data. So with that CDI, you can have those three types of layers. It's also nicely separated within your package structure. You have your model separate. So I tried to apply at least some best practices here. Not all of them are there, like that exception handling with that business exception is not here, but that's something that we showed yesterday. Other than that, there is few annotations, pure Java, and a bit of structure. So it is not that that difficult, that hard. Again, maybe that's my perception. For someone who sees this for the first time, it can maybe a bit confusing, a bit that you need to find your way. But that is what the idea was about the example. The exercise. As I said, it's here. Look in that solution branch, and then you have the same code then I'm showing you now on screen. So unless we have some question for the moment, I think we can go to the question what a lot of people ask themselves, or that people in the world ask themselves: is Java suited for running applications in the cloud? And especially then, should we use microservices? There is a lot of debate around that. Of course, microservices are demonstrated by, there are several reports saying, oh, companies I mentioned already, like Netflix or Twitter even, etc., and all those big companies saying, oh, we are using such a large environment with so many microservices, etc., etc. And that's probably fine, but you, in your case, your company, that might not be maybe the best case, because for microservices there are also some important drawbacks, important factors that makes it actually rather difficult to use. So first of all, a microservice, it's not about size. It's not having to do with size. It is about focusing on a single business domain. For a company, manufacturing company, that can be, for instance, the product management, the product management, keeping your list of products with prices and availability, for example. A second microservice is then maybe responsible for keeping the stock, how many products that we sell normally are already in the stock available, and those kind of things. Other has to do with customer management, list of customers. A fourth microservice can be around the orders, if a certain customer places an order for a product, and etc., etc. And all those microservices talk to each other through that REST, to those JAX-RS. As yesterday mentioned, we are actually using remote procedure call over HTTP, not the actual ID of REST, but if you want to know that, you can look it up what that discussion means. But again, I don't mind as long as it solves my problem. Then it is good enough for me. There is now even lately, the last 2 years, for example, another way of communicating at the gRPC, and so which is then binary, but again, there it is explicitly in the idea that you do remote procedure calls and that you transfer the data in a binary way, not through JSONs as we do here most of the time when we talk about these microservices and REST. And the main idea of microservices is that they are independent. So that means that if I want to update something around my product microservice, then I can just implement my changes, create the application, deploy it, and it works. That's the idea. It all depends, of course, on what you are changing. Because if you are changing the let's call it the contract. If you change the method parameters, if you change the classes that you return from your method, so that is of course immediately reflected in your JSON, which is accepted and returned. But that means that maybe the other services, like the order service that calls your product service, is no longer able to understand or able to call that product service. So there is a really important notion about, yeah, it is independent, and that means also that you can scale one little thing, but you always need to take care about backwards compatibility and maybe have multiple versions even. To continue the story, so if you say, I'm going to change my product, and of course, I'm not forcing that the entire company also updates at the same time their calls to my product service, because otherwise you have just a monolith which is divided in 10, 20 microservices, and then you have even a much worse system than a monolith. That means that you have to install two versions. You have to install your second version of your product microservice, and from that moment on, people can start updating their interaction with that product service, which means that you have to keep multiple versions for a certain amount of time, and that can be a month, that can be maybe 6 months. That depends, of course, on how fast the others are upgrading. And that means that if there is an issue found in one of your code blocks within that product service, you might need to update both of them to fix that issue. It becomes even worse if you have if you need to maintain services which are called from outside of your company, because microservices can be used in two levels. The first one is that you use it for your product maintained entirely by your company. But what if you are calling services from another company, from the government, for example, from general main institutions that provide you some data? There are examples enough. There, of course, you always have that issue that if you change something, you cannot immediately say, oh, from tomorrow on, you need to update, or you cannot use our services anymore. So there you always have multiple versions. And then, of course, you need to keep probably more than 6 months multiple versions alive. And in that scenario, that intercompany thing, there, yeah, you don't have any other solutions, but you see the idea of, I'm splitting up things in smaller parts, and they are easier to maintain because it is smaller. Yes, it's true, but on the other side, the complexity grows a lot, and you need to have multiple installations. You need multiple versions, etc. So it's always going up and down, and the hype, the hype cycle. X number of years, like 5 years ago, everyone said, well, if you're not doing microservices, you're a bad company. Now there is some other, there is again the other side of the hype cycle saying, oh, if you're doing microservices and you're not a large team, and with large, people sometimes say 500 developers, if you're not a company with more than 500 developers, well, forget microservices because you cannot do them properly. So there is always the important factor that you need to analyze, understand your system, and do the best thing for your case. That does not mean that whatever we talked about yesterday and today is not valid, because I'm not using a microservice, because everything what I told you yesterday can be used in any kind of application. Things like that MicroProfile REST client, which is specifically designed to calling some other endpoint, is also valid. As I mentioned, you have those like those government services, etc. So they can be very useful there also. So it is a, if you ask me, a mixed solution, a mixed thing that you always need to take into consideration. Yeah, this is the classic example of Martin Fowler. You know him probably. And indeed, the idea of a microservice is that you have those independent, you can scale them. For instance, if one of those services requires more resources, etc., then it is, of course, resource-wise more interesting that you only duplicate that and not your entire application, that you need to scale everything, where you have then that one larger application just duplicated, and only maybe one little part of it needs to be duplicated, etc. But it is, as I said, difficult to more difficult to maintain, and also more very important. You are from that point working with a distributed system. You know those 7 fallacies of distributed computing. If not, look it up. Things like network will fail, a service will be unavailable so that you don't get a response, and those kind of things. They come then into play if you are using a microservice, which you don't have if you are just using a monolith, because then everything is just within one JVM. It either all works or nothing works. Now you have that entire scala of things that things might work a bit, some things might work, other not, and then you get sometimes, like we had again this weekend with one of the applications from a large bank, that the application worked, but you really could not do anything because there was one little service which was not working, and then that means that you could not sign your bank transfer. So yeah, that was then of course quite annoying. So it appears to be working, but actually it was not working. There are several ways of how you can then set up that entire microservice environment, because then you need a lot more, as I mentioned, but not only these services. Because from the client point of view, you still have probably one entry point, at least one host name or one URL where you can go to. So you need probably something like a API gateway, as you see in the image on the left, which based on the URL itself then routes it to the microservice that that is targeted, for instance, your product, your order, etc. And each of these microservices then need to be able to contact other, like the order needs to contact the product one, which means that they need to know where it is. So you need something like what's called a service discovery. So you need a system that you can query for, saying, oh, where is the product service? And then you get back one or multiple URLs, mostly one URL, and then you have again a load balancer behind that, so that if you have multiple, that you can easily scale. And then you also need, but that's always the case, you need something for identity provider. Probably you have also a separate resource, a separate server for your static content. For instance, if you are using if you have created your application with a JavaScript framework, for instance, you have there, for instance, your static content, your pages, your JavaScripts, which are provided to the client. Another scenario that I found, which is quite similar, is when you are using Lambda functions. So instead of microservices, which are running basically all the time. So your server or your container is running there, although it might not be used. And then people go one step further with those Lambda functions, and a Lambda in that AWS, or what's called serverless, is that your code, your container, it is most of the time a container, but not sure how to otherwise need to name it. Your piece of infrastructure that executes your code is only started when it receives a request. That means that it needs to be that it needs to start up, and then you come and then it processes and it returns your response to the user. That's of course in terms of how much your resources that you use, and then the time of CPU that you use is of course then more efficient, in the sense that if your application is not used, for instance, it is a back office solution that's only used by your office employees during daytime, between 9 and 5, for instance, then why keep it running during the night? But on the other hand, you need to start it up, and then you have the entire discussion, is the JVM suited for these kind of things? Because starting up the JVM, that takes a little bit of time. There are ways, and they are actively working a lot to improve that. Then you get those other alternatives, alternatives that instead of starting it up your Lambda every time there is a request, you start it up the first time, and then you keep it what's called warm for a time. So it is in some kind of dormant state. It's not really stopped. So it is faster activated the second time, but that's then not really stopped. So that means that you are still using resources, etc. So it all depends on your use case, if that Lambda function is cheaper in the sense of cloud cost or not. So be careful with that. Make sure that you understand that those principles really well, all these principles. To be honest, I know the basic things, I know the overview, but if you ask me, can you calculate me if in this scenario a Lambda would be more efficient than a microservice, then I did not do that yet, but I know that you should do it before you switch to such a system, to be sure that you get some benefits, because again, creating all those Lambdas, setting up the environment, that is some time that you need to invest. It costs money also, so you better be sure that it pays off in the end. Coming to those fast startup, so there are several initiatives to make that the JVM starts up much faster. Actually, one of them is already quite old, and is the JDK version 9, where you had modularity built in within the JVM itself. Before JDK 9, the JVM was one big monolith, which just started, and even if you don't use some code bits of the JVM, there was probably already some classes loaded, which might not be needed. So the time to load those classes for initialization during startup, etc., that was just a waste of time. So that that module system, the JPMS, was the first attempt for reducing the startup time. There was also things that are removed. Probably you have also encountered that classes, that subsystems are removed from the JVM by default, so that they are not available by default anymore. JavaFX is one. The support for XML, the XML beans in earlier versions, it was by default available within the JVM. All those things are removed for the sake of getting a faster startup. That was the first thing. The second thing was, I'll try to do it in chronological order. It's not really all on the slide. Sorry for that, I should update the slide. The second thing, what was happening was that there was the trying to compile your Java class to native bytecode. That was already something that Oracle was experimenting with like 10, 15 years ago. And the last few years they got some results. So it was reasonable, easy to do, and it works rather good in most cases, that you compile your Java code to native bytecode, which means starting up is faster, because the JVM doesn't need that JVM loading with all those class loading, etc. Doesn't need to be done at that time. So it goes easily like 40–50% faster startup. So the first request could be handled in a much shorter period after you have started up your process. A downside, what was discovered rather quickly, besides the fact that you don't have that reflection anymore by default, you need to do some additional things around it, and there are starting now to appear some tools that help you with that, so that becomes easier. But besides that reflection, another interesting fact was discovered, that even though we have the JVM and the JIT compiler, it's actually faster. So the performance, of course, the startup was slower, but once the JVM is running and has gathered information how your application works and how your end users call your endpoints and which data blocks and which branches are used and others which are not that used that much, the JVM does a lot of optimizations through that JIT compiler, that just-in-time compiler, because the JVM also compiles data code after a while to native code. Sorry, it's not byte, to native code. So it appears that with that GraalVM, for example, which is doing that native compilation and then can run your process, that you can have something like 5 to sometimes even 10% lower performance during your lifetime of your application. So that's one option. And probably they will improve all those things so that also your native compilation becomes more efficient and it goes faster, because that also takes like 1 or 2 minutes in most of the times before you have your native executable. That performance issue will be handled step by step, and it will improve year after year, no doubt about it. But there is already another interesting solution to combine a bit the idea of a fast startup with still having the standard JVM with this JIT compiler. And that's used class data sharing. It's a rather strange name. It's CDS, class data sharing, which has a similar step as with the native compilation. So you do a step up front, but you just there prepare your classes info in a format that is already used by the JVM. And it is in a read-only memory mapped file, so that you can just add that file to your process, and so that your process can immediately access that, although it stays on disk. But the main advantage is that you don't have that class validation, that class loading anymore during startup. Tests that I did with Payara Micro with that class data sharing proved that you can have a improvement of 30 to 35% of the startup time. So it's less than the 50 with the native compilation, but it is already a nice improvement. And you can then, of course, still benefit from the JIT compiler. You can still benefit from reflection. You can still benefit from that dynamic class loading, because you're still running a classic JVM. The next step, which is not on this slide because it is only a few months old, is actually what's called crack, Java on crack, coordinated restores, and I forgot the last C. That is the idea that not only those class informations are there, but that actually the entire JVM optimization is stored to disk, so that it can already be used when you start up. That's a initiative in that started by the Azul. So you can already use that in a limited version in that open source Azul JVM version. We discussed the different JVM options yesterday a bit, but they are now pushing that also to the OpenJDK so that everyone can benefit from it. And Azul even provide it as a service, so that your JIT data is stored in the cloud for you, and every time you start up in the cloud, one of your processes, it retrieves that data, and that means that you can have benefits of startup time that are nearly equal to the compiled version, so that you also have something like 50% startup time improvement. And with those AWS lambdas, for example, the CPU that you get assigned is related to the amount of memory that you select. So if you select something like 64 megabyte, you get, I don't know the exact numbers, but you get, for instance, 1/4 of a virtual CPU time. But so that means if you select a very low memory, you don't have much CPU. And most of the time, if you need sufficient CPU for processing your user request, you need more memory, because otherwise it's not a problem of fast startup, but yeah, the response time is just that slow because your process doesn't get any CPU from the platform. So if you want something like one CPU, one virtual CPU, or even two virtual CPUs, you get already a lot of megabytes, which means that the memory is more than enough to run a classic JVM. So that was a lot of work, some of investigation done was there by Adam Bean. Probably some of you know them. He's actively interested in that and tried it out, and he made a lot of comparisons. And if you assign enough memory, I'm not saying a lot, if you assign enough memory so that you have enough CPU for your process, like 1 to 2 CPUs, then your Java with on AWS Lambda is comparable for performance to JavaScript and Node.js, because they say, oh, Node.js and JavaScript are much better for running these microservices and these AWS lambdas, but it appears that they are comparable in performance, because you can all do those kind of tricks like that, class data sharing, etc. And since you have enough memory. There is no issue of loading maybe a little bit more memory than the other systems, but it is still a fast system. So if someone tells you Java is too heavy for the cloud, then no, that's not true, because if you are running not a hello world but a real system with some real stuff going on, with real business rules and real processing requirements, and then you need higher memory, you need more CPU, and then Java catches up with all the other technologies, JavaScript, even Go. It's a bit slower as Go, but even bit in relation to Go, it is still very comparable. So that was a lot of info. I guess there are some questions, because there was also a bit of, people say, unpopular opinions about things, or maybe not, and you all agree, which is fine. You don't need to agree, that's also fine, but any comments, questions around this topic, around microservices and that entire Java for cloud, startup time, etc.?
Hello, Stavros. This is Stavros. Since you've mentioned GraalVM, is Payara ready to run on GraalVM, or is it not necessary?
Well, first of all, the term GraalVM is very confusing, because GraalVM is a name that they give to 3 or 4 different things, and they all call it GraalVM. Because you also have GraalVM, which is a normal JVM, which is a bit different, which allows you, for example, the inclusion of JavaScript, of Python, even C++, etc. So that's a I forgot the name, how they call it, but that GraalVM, which is just a JVM like the OpenJDK, can run, of course, your Payara Micro application, because it is a standard JVM. And I have written a few years ago even example how you can combine, for example, some JavaScript within your web application, some JavaScript libraries, for example, that are used within your endpoints which are written in EJAX-RS. So that part of GraalVM, Payara Micro has no problem with, because it is standard OpenJDK-alike one with some extra stuff. The native compilation, that's that should, in theory, it is possible, but it's not yet done, I think, because of the amount of reflection, what is going on, for instance, within CDI, within JPA, etc. So they do a lot of reflection. So by default, if you just run it, then it fails, because those kind of reflections are not explicitly indicated, and yeah, the system does not know what it needs to do, and it just fails. So native compilation is not possible with Payara Micro for the moment. That's new core profile, what was introduced with Jakarta EE 10. I'm not going to say too much about it, because then we are going to tell a lot about things outside of this course, but I just want to quickly mention it. That core profile, which has a new CDI Lite, as they call it, which is less dependent on reflection, etc., is also a limited set of specifications that is more designed to having that native compilation in mind. If you're interested in that, I'm giving a presentation on that on December 6th, in 2 weeks, around 2 weeks, on the Jakarta One live stream around core profile and what that can mean. So if you want to know more about it, then you should tune in. It's a free online event.
Okay, so how can I find some information about this event?
Jakarta one live stream.
Okay.
There it is. So here, and then you can register yourself.
Okay, thank you.
And I'm here after the intro. I'm the first speaker. Explore the new Jakarta EE core profile. But 12 o'clock Central European time, so it should be all for you, easy to follow. So that's one.
Okay.
You can use Payara Micro with that CDS option. I have here with that warming up that describes it, but this is not my info. That was from a colleague who was at that time. If needed, I can try to find the info. What you need to do, which steps you need to do to activate that class data sharing for Payara Micro, and that you then already have that 30% improvement. Again, is that enough or not? That depends on your use case. If you say, I need to get my process started within 1 second, then yeah, even that CDS will not be enough. If you say, I need to start my Payara Micro instance within 3 to 5 seconds, yes, then that is enough. So I hope that answers your question about how you can use Payara Micro specifically then on all these types of things. Oliver also mentions, why does people say Java is too heavy, slow? Well, it is used in deep learning. The deep learning for Java framework library, for example. This is still about business applications. Yeah, it's all and all understandable, I guess. Other frameworks, other technologies which are faster in startup, they are pushing that, of course, saying, oh, Java is too slow, because they want to promote their own thing, which is not bad, don't get me wrong. But of course, they forget that there are real use cases behind it, and that it's maybe not just the difference between 1 second and 3 seconds that is important for everyone, because in my opinion, for 99% of the companies, that difference does not make any sense at all. Any other question? Okay. Next thing, what I like to cover is one of the micro profile specifications, which is next to config one, something that I really enjoy using it and is really useful in my opinion. And it is a way of that for type safe invocation of remote services. So RESTful service over HTTP. Think about remote procedure calls. Yes, again, I'm moving back to those RPC style of calls, but the idea is that you have actually you perform what looks like a JVM method call, but actually you're calling something remote through the JAX-RS client, and you are using JSON behind this scene. So let's have a look how that works. If you want to have the same, or is it the same, or very similar example. Again, use that start microprofile.io and use here the REST client. And if you select this option, then you will have an example which is either identical or almost identical to the one that I will show you. Or of course, you can look at the GitHub. And the example, of course, creates two applications, two services, because you have a service A which calls a service B. Just using standard microprofile. I'm going to switch, then it is in my correct branch. If I push it later on, then I can do it. That is available there in that microprofile one. So you have a standard JAX-RS one. And yeah, you have here the client controller, so a standard one. But I'm injecting here a REST client. I remember what we said yesterday, that JAX-RS had the client one. Otherwise, you need to look back at that example for the client, so that you can have a client, you can specify the URL, you can specify the headers, you can specify that you need to get, but it was rather tedious, low level, all those steps that you needed to do, which was not interesting. Here, microprofile REST client takes another approach, saying, I'm annotating this with the REST client, which is that typical qualifier most of the time, but microprofile implementations then need to perform something, because actually you have here an interface. You have here an interface that says that this should become a REST client, and that if you call this do something method, then the parameter that you specify will become a path parameter. So that's pure the JAX-RS one, but now used in a different way, saying not retrieve me from the URL the value. Now it is saying, well, this parameter, if I call this method, will become a path parameter like this. So you have specified it in the path. And yeah, then the system will generate some kind of proxy. Not sure if you can call it a proxy, but on the fly implements dynamic code that will back up this this interface. So it will actually do something when you call this do something method by calling your remote endpoint with information, and in this case return the string which is returned as body of your call. Since this will become a injectable, you need to specify the scope. Most of the time it just, of course, is application scope. So if you call this do something method, it actually calls something remotely. So it looks like a regular JVM method call, but it is actually a remote RPC, a remote procedure call to something else. There's, of course, one thing missing. Where is it hosted? But of course, that is different between test, development, and production. So that's why it comes through configuration, where you say, this is the interface. That's the name of my interface here. Microprofile REST URL is this base URL. And then, of course, there will add this path parameter for the value that you put it here, how you call it. Service B on the other side, yeah, that's just a regular one. So it just here it does not need to know it. Microprofile REST client, as the name says, it is pure on the client side. So it doesn't need to be that this service B is Java. It can be whatever on the internet, as long as it follows those REST principles, in the sense that you have those URLs and get, post, and those kind of things, then that's fine. So let's start those things up. Again, for the sake of having the location, or did I have it here? Yeah, I have it here. So I'm going to have here I'm going to put a title to this window. This is my service B. Payara Micro starts up. Now I'm explicitly assigning a port, of course, because otherwise, if I run 2 times Payara Micro without any configuration about ports, then they both try to start up on port 8080, which means that will fail. So I have now here my application running service B, data client service with that parameter. And on that service A, or to be sure, there is a target already, but I want to be 100% sure I have the latest version. I'm running my first one here, so title, this is service A. And so when I call this endpoint, client test with a parameter, I'm just forwarding it to service B, which is of course not very useful, but it is just to show you how things work. So I keep it as simple as possible. If I do a curl to service B, this is the response which I get from service B. See, service B, processed parameter value and the actual parameter. So I'm calling service A, which calls on his part service B, sends back the return to A, and A returns to my client here. This is your result. That MicroProfile REST client is interesting for several reasons. One of them I find is because of the simplicity of how to use it. This is much easier than trying to do something. You have something like clients. How is the REST client called? Because for those that you remember yesterday, I had a client that you need to instantiate. Was it new builder? No. You had a client to instantiate, and then you had to define the target. You have to define the entity that you send. You need to define the get, etc. So it's quite a lot of work. This is of course much easier. You just model your remote service, saying I have there somewhere a procedure, remote procedure. That's this name does not do is not important, but it has some parameters. It has some return values. Not showing it here, but if you have here, like we had before, like a person or something, then it automatically converts it from and to JSON and those kind of things. Also for your path parameters or your body. If you don't have a path parameter, then it's your body. So you can do a post to that remote service. And you can easily configure it saying, well, this is a location through MicroProfile config. So it comes configurable for test production, one of those important aspects. That's one thing why I find it useful. Second reason is that if you're splitting up your, you're doing a refactoring of your application, and you maybe had already one monolith where this was a purely a CDI bean that you injected, and you called that service, and now you're splitting up your application by putting that service in a second microservice, then actually you don't need to do a lot. If it was not an interface, then of course you need to create the interface, you need to do an annotation, but most of important, okay, this is now a simple one with the one statement, but the actual code does not need to change. It stays as it was with the monolith. You only have the way how it is called. Was it locally, then it was direct. If it was remote, then you could do it remote. I even did some kind of proof of concept beginning of the year where you have the possibility to have the same code base, more or less the same code base, that you can either package as a monolith or that you can package as a distributed set of services. So without touching the core functionality, just by defining those things, is it locally, is it remote, etc. So that is then really flexible. Of course, if you start from creating a greenfield project in that way, then yeah, it is nice, but of course there is an initial overhead also to get started with that kind of thing. Can I use the configuration file like this? The question is if there is a load balancer between the client and the server. Yeah, sure, because then you just define here the URL of the load balancer. And then the load balancer takes care on which actual instance it will forward the request. So yes, that is the idea. Yeah, now that you mentioned this, you remember what I said from one of the slides, that yeah, you need that service discovery at where is my per product URL located. People tend to forget about that entire service discovery, especially if you're working within Kubernetes, etc., because you can define services there, and you say, call me something like product on port 8181 or 8180 in this case. And this product is then defined in your load balancer or whatever, and your load balancer is the service discovery. And people are much more familiar with the load balancer than with a service discovery product. Of course, the functionality is not the same, I agree, don't get me wrong, but it also gets the job done in most cases. So that's one of the things that you can do, and ties into your question about load balancer, which is on the chat. So REST client, one of the nice things, in the beginning, it is of course a bit confusing of which URL is he now assembling. What is the final URL he will be calling? So because you have here a bit of path elements, you can, I think, also have here a path element on the interface. Part of the URL is here. So what is the URL that he assembles out of that, all that? So then I'm going to use one of the things that we saw yesterday that can be used for debugging. So don't use this in production, I guess, which is a filter. We mentioned yesterday one of the possibilities to have a filter. In that particular case that we covered yesterday, it was a server response filter. Now I'm using a client request filter. So that's a piece of code which is executed by the client when he performs a request. And you can get the client's request context, and you can get the URI from that. Because if you do something wrong with the configuration here in the file, or here on that service level with the path elements, etc., the only thing that you see in your logs is 404, that the remote URL was not found, but you don't actually see the actual URL that he tried, which was not existing. So you made an error somewhere probably. But yeah, what was then the URL that he tried and what was wrong? So with this client request filter, you print out the URL that it tries. And you have seen this maybe, then you see the remote service URL, he prints out the actual URL. And then you can see, oh, is this correct? You can even try it out from this point of view. You can also try it out. You see it works, etc. Then you can have more debugging information. You can more info around it. This filter, how do I add it? You have seen it probably on the fly on the service. Here I say I'm registering to the proxy this filter here. That's also something MicroProfile REST client thing, so that you can, on top of the standard functionality, as I said, that converts your method call to a remote call, he also adds all kinds of JAX-RS functionality on top of that generated code. REST clients, find it very useful. Anyone that has another question around that? There is one additional step, but any chance to debug the add tags? You mean those kind of things? Yeah, then you probably need to do a remote debugging session.
Rudy, my question was regarding what if I forgot where I injected this register provider, for example? So I want to change back from debug to a normal client filter.
Okay.
So how can I find where it is? So this is a question, I think.
Yeah, probably if your IDE, so you know that you have this request filter and you probably can find the class, where is it used, and you can probably get the usages. And
okay, it's provided by IDE. Okay. Yeah,
that's provided by the IDE. As I said, do not use it in production, etc. So you probably have here a config. If not production, then do something. Otherwise, if it is production, then don't do it. And debugging, yeah, that's because it is executed when your Payara Micro runs internally, because you don't see that implementation, you only have the API. Yeah, you always have to do a remote debug session. Any other question? Don't see anything in the chat. No hands up by someone. So remember that we yesterday indicated that you can do asynchronous calls. So down on the server side, that you received a request and that you can do, and then that you can use that managed executor service, that you can use a different thread pool to apply, so that probably your responsiveness of your application improves. That all depends on what you're exactly doing, of course. With this MicroProfile REST client, you have also the possibility to call your methods asynchronously, remotely. So just by doing this, do something, it's not synchronous, but immediately it becomes asynchronous. How does that work? I have here a service. So in service B, again, there is a something heavy calculations, 2 second sleep time, but you get the idea. I do something remote that takes 2 seconds. So I'm not willing to wait for those 2 seconds because my service A logic can do at the meantime, at the same time, something related to the user request, which is also required. So I'm not going to wait. I want to do things in parallel. This here is not asynchronous. You see, this is purely a JAX-RS which return a string. There is nothing asynchronous. This is now about asynchronous on the client side. So that's different. Yesterday it was asynchronous on the server side. So I have my heavy service modeled here, but I'm saying, well, it does not return a string because I want to use it asynchronously. I'm again going for that completion stage, which we saw yesterday for the first time. When I call that heavy service, then I get a completion stage back. I can do so immediately. So I'm not waiting for the 2 seconds before this method returns. I get immediately a completion stage back, and in the background, in another thread, the call is performed to that remote service, and the result is put back here on this completion stage. So I'm continuing in my client to do some things. Again, I did not have something useful to do in this demo, so I'm just waiting. After that time, I'm saying, okay, I'm ready, and I'm waiting for the result. I'm waiting for a result, or if the result is already available, because you have no idea how much time it took, for example, then you ask for the actual value from that completable future. Completable future is also which we used yesterday. Here we ask for the actual result, which is, in this case, our string. This will wait or returns immediately, or this will wait until we have the actual value. And then we can use that result, which we have received here, and get it to the client, which called us service A. So if we are doing that in our test setup, it is a bit, you have to be looking a bit at the logs and the timings, but you can see that it is going asynchronously. So first of all, I call my remote service here, and that is at a timestamp of 16 seconds.4. And then you see I'm immediately continue in that caller 16.5. So that only took 100 milliseconds. That means it did not wait for the 2 seconds. Here I'm getting the request in 16.6. So you see I get even the request on my other the first entry after I continued in A, and 2 seconds later, here 18.6, which is 2 seconds, I am returning the result. Here we had 1 second processing time, and now I'm ready for retrieving the result. So it's waiting. The result is sent back here. 18.6, 11, 18.6, 15, I got the result, and I can return to my client the result after some substantial amount of calculation, blah, blah, blah. It was just a wait time. You see, that's a very easy way to also on the client, and that's unique in MicroProfile REST. You don't have, well, you can do that also with the standard JAX-RS client, but you need more work. You need to do more things yourself there. Here, You just need to define that it is a completion stage, and everything is done for you. If you are doing it pure in with JAX-RS, then you need to set up another thread, create that that's completable future, etc., and those kind of things. Here, that's all done for you behind the scenes. Combined with the fault tolerance, what we will cover after the break, when something goes wrong, this of course is a nice way of calling endpoints synchronously or asynchronously with that completion. Any questions about that asynchronous? So just the overview, define the remote endpoint contract with your interface and make also a synchronous call on this client side that yesterday we had a look on the server side, how you can do asynchronous on the server side. So if we don't have any questions for the moment, then I propose that we have a break for 15 minutes again, so that we come back at 45 after the hour, because we are not all in the same time zone. There is a question, fine. Is there any recommendation on how to decide to wait for the response? Not sure if I understand it completely, but at a point where you say, I really need now the result of that remote call, the only thing that you can do is wait and get it here. Then not sure what you mean by on how to decide, how to decide when to wait, not how to wait, when to wait. That, I guess, depends on your use case. If and on the information that you know, I'm going to call that remote endpoint, and the owner of that endpoint should give you that info. I can expect a result back within 500 milliseconds or something, or I can expect a result within 5 seconds. So based on that information, you need to decide, is that 500 milliseconds okay to wait or not? Of course, you can always immediately go for asynchronous all the time, but know that there is a little bit more overhead on asynchronous, in the sense that it needs it is using a additional thread pool. If I remember correctly, you can configure that thread pool within Payara Micro, but I'm not 100% sure. So you can either say, okay, I'll always go for asynchronous with the maybe a little bit more overhead of resources, memory and CPU, or I can base my decision on that info from that endpoint provider. It takes 500 milliseconds, so yeah, maybe I can wait, or it takes 5 seconds, no way I can wait. If I never call the .getWith, I get an HTTP error because there was no response. No, then that happens in the background, and if I don't do that, this line, I just ignore the response. If there is, suppose that there was no response at all from my remote endpoint, then then it either waits indefinitely, or you have to then, of course, to define, you can, that's already a peak for for the next microprofile specification that we are going to cover, that you define here a timeout, a fault tolerance. I'm only willing to wait for this for a maximum of value. I'm going to say for a maximum of 500 milliseconds, for example. Because otherwise, if you don't do this, and it might be the case that your remote never replies, if it disconnects, then of course you get an error and then and those things. But suppose you have this situation where you have a service that just swallows requests and never ever reply them and keeps the connection open from their side. Well, then yeah, this will wait indefinitely, of course. So you need to make sure that you have the things like this. Okay, good questions, real world questions, because although this is already a bit more than hello world, it's still not real world. So see you all in 15 minutes for the next microprofile specification. So, okay, we are going to discuss a few more microprofile specifications, or at least not all in detail, but you should be able to get the idea of what they are doing, what their core goal is, and so that you can look it up. Yeah, first of all, you have also the microprofile Open API. That's already available by default. So if I go to localhost, I'm going to use that second one, which will give probably a better one. I get a what's generally known as a Swagger description, because Swagger was the first framework product that this started using, that provided that for endpoints. That it's a schema, it is a description of your endpoints. Now that has evolved to a also a specification, so it is it's a standard. But yeah, probably a lot of people still refer to this as the Swagger info. And as you see, although I did not do anything, I get basic information because it checks those JAX-RS annotations within your application, code, and it sees that there is a part called data client heavy, with it's a get, which is the response, which is just a string, etc. So you can have these information already there, but that's very limited information, only what it can retrieve from the annotations. There are other annotations that you can put yourself on the in your code. It's an option. You don't need to do that. It's not required, but it allows you to have more information there within that generated one. So for instance, you can have the proper description saying this will perform calculation XYZ for the parameter or whatever. You can even write a novel there if you like. Probably better that you point them to some documentation instead of writing a novel here. You have several of those annotations. If you follow them, as you have the I thought they were all together, but it seemed that they're a bit spread out. You have the header annotations that describes what the header comes in, the media. If it's returning JSON or not, I don't. Is it there? Yeah, content you see // here, so it's not specific. Star / it's not specifically said if it's JSON or not. So that's all kind of information that you can specify, etc. So if you have parameters, you can also define them. For instance, I'm going to here, then I can have here a annotation which describes then the parameter, the description again. So I need to member description. Used for blah blah blah, etc. So you can give additional information about the schema, what will be generated, and that will then eventually end up here. Can be used in two ways, either just by developers to just read this and then learn more about it, more about some details. Or there are even tools that, based on this kind of schemas, generate your Java clients, so that you have generated code that is capable of calling your endpoints. And if I am correctly, OpenAPI code generator, there is now recently one for MicroProfile also. Here, the OpenAPI. This is now the Open Liberty documentation, but it is using the OpenAPI code generator. I think it was, or do I mistake myself? So you have to look up then. This is for specifically for Jakarta EE, but I thought there was also one that actually can generate your code for it. So it basically generates things like these services with the correct path, etc., so that it matches the info here in the OpenAPI schema. So that are the two ways of using it: pure documentation, textual for developers, or as a basis for generated code. Useful, not necessary, of course, but yeah, think about your fellow programmers that need to use your API, so at least give them some documentation. Next one is default tolerance. So as mentioned, microservices basically becomes a distributed system. The 7 fallacies of distributed computing is there. So that means that several things can go wrong. So when I call my remote endpoint, and yeah, what happens? And then one of the questions there was, what happens if I don't get a response? So one of the things that you can do is this timeouts. You can, with the starter, you can generate a few examples. If you tick the, I waited more than 30 minutes, so then that means that it times out. If you tick it, then you also have a few examples of them. They are all quite well described in the documentation of MicroProfile, fault tolerance specification. And yeah, you can use them in both ways. So for instance, here that was not the idea. If I have timeout, that's that can be used, as I mentioned here, but there are other use cases that you are willing to wait at maximum 500 milliseconds. That does not need to be asynchronous, so that also works on a normal one. But you can have other ones, I'm going to use service B again. For instance, although this is just a regular one, I can also have here a timeout, which means that if I don't get a response within that the time that I specify, and by default it is 1 second, of course you can change it, then the interceptor, because it is it generates an interceptor for this kind of functionality, then the interceptor already throws an exception, which means that your client gets back that there was a timeout and that it did not respond properly in that time that you specified. Of course, your processing here still continues because it was doing it in another thread, so it does not stop your processing on the server itself, but it at least gives your client info back saying, oh, well, you specified 500 milliseconds and we went over the time. Another interesting one, which is here also described, is a, I'm going to use this one. I'm going to describe the others in a moment, but bulkhead, because I'm now here. That's also one that's here mostly used on the client side, saying bulkheads. Bulkheads, is there no timeout? I thought it was about numbers. Oh, you see, value the numbers. Why I get that timeout? And IntelliJ, you were wrong. For instance, you want to protect this piece of code because it can be resource intensive or whatever, and people, especially if it is public accessible, people try to find out those endpoints which seems to be resource intensive. So what they do, they just launch a denial of service attack by calling this 1,000 times in a concurrent way, which means that your server will blow up probably. So if you say that under reasonable usage of your own application, that there will be at maximum normally 10 users concurrently accessing this method remotely, then you can say for a safety margin that if there are 16, so client number, request number 16, which access this this method through that endpoint, it will be rejected. So you get, not 100% sure which error you get, maybe not here. There is, and then there is a certain response. You have a certain response. Then it's not defined which one, but okay, that's done in the specification document. You get just denied, just to protect your endpoint, so that someone does not blow up your server by just launching enough requests. There are other ways, of course, to protect that. There are on the firewall level, there are how is it called, the WAF file, the WAF systems, the WAF system, I think it was called, the also kind of firewalls that dynamically try to analyze the traffic and detects that there is something unusual going on, etc. But you can also do it in code, where you say, well, number 16 has no luck today, and you will reject it. Of course, if responses get sent out, new ones are allowed internally to be accessed. Another one is more or less similar, Not exactly similar, but in the same category is circuit breaker. Of course, this is not a good result, but suppose that this method does some calculation stuff. It also calls remote things, like for instance, it calls remote endpoints to determine your monthly payment that you need to do for your loan and those kind of things. But sometimes, yeah, there errors happens because that remote system is not available or whatever. Then you can define a circuit breaker. And a circuit breaker is just like that electric circuit breaker in your house. It switches off when things go wrong. So you can define here here the failure ratio and the request volume threshold. So it analyzes the X number, the latest X number of requests, and if the failure ratio is too high, then it switches off your circuit breaker. Because the idea is, well, if it fails, let's say or let's say it fails 70% of the last 20 calls, then probably this time it will also fail. So why bother trying and just return something to the client or saying, whoops, no, it's not available. And then you have some delay. By default, it is 5 seconds that your circuit breaker stays off. After that time, there are again some requests allowed, and if they are successfully, the circuit breaker goes again fully on the open stand and people can use it again. The idea behind that circuit breaker then is, of course, that you, if something does not work, that people go say, oh, I have had an error and I try and I try and I try and I get an increased traffic, because yeah, that's how the psychologically people work. If something does not work on a website or an application, they try it again and again and even multiple times. So you even stress your server more, knowing that it will probably not work. So you block it already at that point, saying, wait a bit, our internal system, whatever, for instance, will pick up by Kubernetes will see that there is an issue and start up a new pod, which will take probably a few seconds. So that's the reason behind this 5 seconds delay, for example, so that things get back to normal again after a certain delay. But it's, as I said, more or less also related to that blocking if there are too many that blockhead. Retry and fail back. Yeah, you can use them, or mostly used again on both sides. For instance, for the timeout. Suppose that you say, okay, I have a timeout of 500 milliseconds, but don't give up after one time. Retry, retry 2 times. So my call did not return the first time within 500 milliseconds, or there was an error, because errors are also retried, and try the second time, because I know that that remote service is a bit flaky, and 1 out of 1,000 it just fails. But actually, if I call it the second time, it works fine. Yeah, that happens sometimes. Then you can define here max retries, and the end user or your client does not see anything about it. Of course, it takes more time, but it just retries it again. Suppose that you say, okay, I'm not want to give just a plain blunt error HTTP status to the client saying, oops, it did not work or whatever. But I want to give him some reasonable default, or saying that something was wrong or whatever. Then you can, but no, it's fallback. So you can define a fallback. So if timeouts either without a retry or after retry, it still fails, then you can define a fallback. And with fallback, you have two possible ways. You can either say, call me this method. So you can have, yes, my code is right, but I'm here. I can say, I can define a fallback method, which is not the ideal. And you see immediately why this is not ideal, because then you have a, for instance, that returns then a string. Then it will call this method, not 100% working in this case, but you can use it also on a JAX-RS resource, and there it makes more sense that you define a method. But what I mean, it's not ideal. This is hard-coded as a string, so if I rename this, well, it no longer finds it. So that's not ideal. A better method, a better way to do it is the is here, where you need to specify a class, and that class needs to implement this fallback handler. So it needs to implement this this method, which is which makes more sense, of course, if you want to do more type-safe coding, not using method names in strings, for example. There are good resources on the internet that describes it, MicroProfile, fault tolerance. So if you want to know more about it, then you can look up, for instance, the document where it is described more in, that's not all of them, but that's just a retry, but you know what I mean. Internet knows more than this one. Rick Peel is also a good one. I'm going to say it. So he describes it also, how you can do those things and what the specific cases are for each of them. Health and metrics, mainly for that observability, where you have this kind of information. This is already in the Prometheus endpoint. Metrics will be replaced by a new specification, which is built on top of OpenTelemetry. But yeah, for now, in that MicroProfile version 4, you have this metrics, which already exposes basic data of your JVM, like CPU, you use it, SEEP, memory usage, etc. You can also define your own metrics. So you can define, let's do this. Start MicroProfile, let's select all, and just to keep consistency, I'm going to use JDK 11, downloads, and then let's open it. There is an example in for a custom metric definition. Downloads demo. Metric. See, I have, you can define, okay, I've opened demo and not service A and B, that's why I don't, maybe I gotta do load and it will fix itself, yeah. Except it stays in error. I can define a custom one. For instance, I can define a counter and I can give the name, and that name will then appear here in that output. Where was it here? then that name will appear there, and I can define what happens with my counter. For instance, I can increment that counter due to some kind of logic which happening. For instance, number of orders placed during a day. So if you have you want to track in your system some KPIs which keep track of the number of orders that are placed on the internet on your website, and you can have this something that is then exported as part of this in Prometheus. By default, you can have it also in JSON. And then, yeah, you can have it in Prometheus, then you can have it in dashboards, you can have it whatever you want. So that's one option to use it. Another custom one here is that you have a timing information. So you have a histogram of timings. The 5% quickest responses were was that limit 50% of the request was served within that amount of time, etc. So that is other timings that you can create, a really custom one or using a default one, more or less, which is already predefined, which can be interesting to analyze how things goes, etc. All those things are about observability and knowing more info of how your system behaves, because if it's running, it's there a black box. So if you expose all that info, you can at least use it or analyze it. These metrics does not say a lot, of course, because that's pure basic the data. You need to interpret it. If just to where was it here? System load average 2.9. So that means actually almost nothing of CPU is used. But if there is another value, is 70% of the CPU you use it, is that a good thing or a bad thing? That of course depends on your system. If you know that you have a application that is not used that much, and you see that your CPU is constantly above 80% or something, then you think, well, there is something wrong. If you have a highly used system, which is constantly under normal, between brackets, operations between 70 and 90%, because you have designed it really well and it is behaving as expected, then yeah, 80% is fine. So metrics, what I want to say is metrics are pure the data. There is no interpretation behind those data. That's something that you can do with the health specification. There are no checks here now because I did not define any, and there are no default ones because, as I said, 80% CPU can be fine or not. That depends on use case. You have to configure that yourself. Health, the health endpoints, as you can, for those who know Kubernetes, these health endpoints are typically used by systems like Kubernetes for determining if your service, your application, your process is still running fine. If there is an issue, you can return the status down, although it's still responding, so it is not really down, but it is not really healthy, which means that Kubernetes will say, okay, I'm throwing away that pod and I'll create a new one, in the hope then, of course, that that new one behaves better and that there was an issue because someone called something which caught up in an infinite loop or whatever, and those kind of things. So these health endpoints, and you have different. You have the health at startup, you have the health liveness, and you have the health readiness, and you can define custom checks. For instance, if you can implement a check. That's one of the things that I did once, is that, for instance, if my application cannot access the database anymore, for whatever reason, maybe a network error, then I give as a health check as a response that it is down. Because if my application cannot access database, it has no sense that we still try. So Kubernetes, in that case, if it's running in Kubernetes, it will drop my pod and will recreate it new, hopefully without the network issues then at that point. Otherwise, you still have an issue. And you can define if it's used for liveness or readiness. That's just depends if your check is part of liveness or readiness URLs, or you have now also then the startup, if I'm correct, yes. But by default, Payara Micro gives an up when there is an application deployed. So as you saw yesterday, I can just do Java -jar of the Payara Micro jar without any application. And then at that point, my health status will also say down. So by default, it gives you an up status when there is something running, an application, but then you have to decide, you have to interpret these metrics. For example, based on CPU, you need to define based on your custom knowledge that an application will not work properly if there is something wrong, like database is not accessible. So that's health. Health and metrics go a bit hand in hand and important for that readiness. Another one, and as usual, people don't have time to do, it's not service B. This service B, don't have time to go over security. So again, not going into detail around security, but I at least want to mention that there is the MicroProfile JWT and the JOT specification, which handles those JWT claims in the header. You can send to an endpoint a request, and within the header you send that JOT token, which is a JSON, which is part of that JSON is encoded with a public and private key, or depending on how you do it, just coding, just signing or encryption. And that means that your client can verify if it's a valid request. That's one thing, but also within that token there can be information about the user, for instance, the roles that he has. And no, it is not a security hole that you put those tokens at those roles in the token, because as I mentioned, they are signed with a certain key. So if someone tries to tamper with it, they don't have the correct key. So that means that the verification on the server side will fail. All that part of getting, taking in that token from the header, parsing it, checking, designing, and all those kind of things, that is something what MicroProfile JOT specification does for you, so that you can just define something like here. So this REST endpoint is only allowed by users which have the protected role in that token. So anyone who does not have that, they can try, but they will receive a 401, not authorized immediately, so you don't need to do anything about it. What is needed here is that you define that the MicroProfile JOT specification is used for logging in users, and you need to declare all the roles which you are expecting, I mean, what you are using within your application. So it's fine that there are other roles supplied in the token, but you have here protected, so that that means that you can use here that role protected. If you have here protected, but you don't specify it here, then it will not work. So also you need to explicitly say the roles that you want to use in your application. So again, it is a whitelisting instead of a blacklisting. You explicitly need to say what will be used, and so it's not that just anything what is defined in the code is allowed to be used. On the client side, there is no specific thing. There are plans, but most of the time it's not needed, but there are no specific things to help generating those tokens, because those tokens are most of the time provided by you by the identity manager. So you have a way of authenticating that can be OAuth 2, for instance. There are several products like that that provide it even online. You have the Auth0, or you have Keycloak if you want to have locally. So they provide you those tokens after a user has logged in with their credentials on that system, and then the client receives such a JOT token, and you only need to validate it. So that's the reason why there is not really a need for a specification or parts in the specification to generate it. Of course, in these kind of hello world things, it is more useful. So there is here the generation of such a token. But again, that's with a specific framework. It's not a standard. And what we need to do then in the configuration also is then define how the key. So we have here a public key, which can be used to verify the signing of such a JOT token. And yeah, we have also here, and then this public key will be used, but I thought you needed a indication in which file, but okay, I have to check that. So that you have, and so that this key is checked, so that you know that you cannot just send any kind of token which is signed, only tokens which are signed with that private key. And this public key is then made available by those identity providers like Auth0, etc. So then you can even define a URL so that you can dynamically load them instead of putting it here in the config. So that is around MicroProfile. So let's head to MicroProfile specifications. Let me go back to that image. I think we have then covered all, but I want to show you the images so that it's not the latest one. This one is, let's here for that one. That's the one that you can use with that version of Payara Micro that we are using. So any question about those MicroProfile? We covered the most important ones, like the config, the REST client, and the open tracing is about tracing your request. That requires always the setup of a third-party tool that captures those tracings and provide you the analysis. So that's why I did not include it. It's a bit more work. Also, that does not mean that it is not important, but as for this course, I did not have enough time to go in a lot of detail. There is an example, Payara Micro Open tracing. There is here a documentation, but there is also, I thought there was a blog here with Jaeger, which describe, you see, I remember the things that I wrote. One day I have here a video, how you can set up those things to track your calls if they go from one microservice system to another. Let's put that in the chat for those that are interested. Any other question? Where was it? So where was my search? In the meantime, feel free to type in a question here. So we have covered all, let's say, more or less all the main building blocks for any kind of application for Payara Micro. So by now you should have an idea of how you can develop microservices with Payara Micro from the code point of view, CDI, JAX-RS, config, and things that comes around like fault tolerance, metrics health, and those kind of things. Any specific question around that topic? It's of course not the end, but we will now cover some specific cases. Until now, it was probably usable in all of your applications, what you are going to write, and now we're going to cover more specific cases. Okay. Next. Next is data access. Data access is a very large area. So there are like 350 different data solutions in the world, from the classic databases to the NoSQL solutions to things like Kafka streams, etc. So it's completely impossible to give an overview of that, of all those possibilities and the different aspects. Of course, the most classic ones are a database and NoSQL solutions. And I assume, and time will tell me wrong, that probably most applications today still use a traditional SQL database. MySQL, Postgres, Oracle, whatever. So that's something that I'm going to cover and give an example how to use that in combination with Payara Micro. Also because that SQL one is standardized within Jakarta, the JPA, Java Persistence API. So it does not mean that you cannot use NoSQL, something like MongoDB or whatever, you can still use it. But yeah, it's just, you need to look up what you need to do for MongoDB. For example, you follow that tutorial probably, and you just implement, use that within Payara Micro application, and that should work fine. There is no specific functionality, however, which is provided you by Payara Micro for those kind of solutions. Databases, as I said, you have the JPA. Currently, there is a new specification underway, which is called Jakarta Data, something which combines the ideas of Spring data, Micronaut data, Delta Spike data, and those kind of things. So all those good things are now assembled in Jakarta Data, which means that you have something more than a database. You have a more high-level approach to accessing data. So Jakarta data, one of the things what will be supported is, of course, JPA, the SQL databases, but you can have other kind of sources there in that Jakarta data. So that's something what will drop eventually. I know Ottavio is putting a bit of pressure on those things to make sure it happens rather soon than late, but I cannot say if it will be in Jakarta 11 or not. That's of course something that we will need to see. So therefore, long story, just to say that I'm going to focus still today on JPA and a database. And as I mentioned, also MicroStream, where you are using the JVM as memory, because within JPA, you always have to use, or probably always need to use some caches, at least the first level cache you always have, the second level cache you probably need, because you need things locally within the memory faster. So why not consider your JVM memory as a database as is? So that's MicroStream, which we will cover just after lunch then. So before lunch, we will concentrate ourselves on database. And yeah, JDBC, Java database connectivity is already there, I think, since Java 1, if not Java 1.2 or something, to access your data in a database, data stored in fields, tables, etc. But that is, of course, a very low-level way of working. You need to write some boilerplate to retrieve the data. You always need to make sure that you close your result sets, close your connections, blah, blah, blah. So it is fine. It is the most flexible thing and also the most performant thing, that's for sure, but not the most easiest way to write code to retrieve data or store data in the database. So then the idea was, okay, we need what's called a ORM, object relational mapping, so that we can just stay away from that relational data model as much as possible. We just concentrate on Java. We define a few annotations that make the mapping, hence the name, the mapping between our object and a table, between a property and a field, for example, and those kind of things. And then we write SQL-alike things. It's not pure SQL that we write there. We write Hibernate query language, JPA query language. So we write actually queries to select Java objects. If they are not found in the cache, then that Java query is converted to a SQL query and executed underneath by that JDBC for us. So that JDBC part is completely, or most of the time, hidden. From my explanation, you already imagine, for those that does not know how these things work, that it is nice, easier, but of course it is an overhead. It is an additional CPU required process, memory required process to have that ORM, to have Hibernate, that to have JPA in general working. You can have all kinds of performance issue, typical at the n+n query problem for those who are familiar with JPA and Hibernate, where too much JDBC queries are created. Instead of creating only a few, it creates a few hundreds of them, depending on how you have done your mapping, on how much info you have given JPA, how that he needs to convert the JDBC, etc. So it can be challenging to do that, but it is still a very widespread and useful way of accessing data in a database, of course. So yeah, you need the ORM tool itself. That's obvious. That's included within Payara Micro because Payara Micro has an implementation of JPA. JPA is that ORM tool. For those that want to know, Payara Micro includes Eclipse link, so not Hibernate. You can switch it, but by default it is using Eclipse link. And of course, you need a JDBC driver, so that is always required. Payara Micro does not, and server also, they do not come with drivers included for the databases. So you always need, with server, you need to install the drivers. With Payara Micro, you also need to provide them when you start up your application, and you need to supply the driver, the location of the jar file with the driver, so that your ORM tool, Eclipse link, can connect to the database. And then, of course, you need the configuration to access the database, the location, the credential, and the username and password, for example, and some other configuration options. So that's something that I will cover now. That is how that you can specify all the bits and pieces so that your application through Payara Micro can connect to the database. Once you have them all in example, once you know all of them, again, it is easy, but there are quite a few bits and pieces. So if you're missing them in the beginning, then yeah, it does not work. And then sometimes a search starts for what am I missing? What have I did wrong? Why is it not picking up my configuration, for example? I'm going to stop these things. I don't need them anymore. And otherwise, I will have an issue if I start new Payara Micro instances. I'm going to close this one. No need for that anymore. I'm going to use the JPA one here. So again, we, as I said, JPA is included in that web API. So we don't need anything else in our dependencies. Again, just that web API dependency as on the scope provided. But there are a few things that we do need now, and that's one of the things is this configuration file is it's called persistence.xml file. And the file defines already major parts of your configuration. For your ORM tool, sorry, I wanted to just make it bigger here. For your ORM tool, because within the tool you have what's called a persistent unit. If you have multiple, you have to define it in the code which one you're using. If you're only using one, then of course system figures it out that you configure this one. But suppose that you have maybe a requirement to access multiple databases within the same application, then yeah, you need to define multiple, and then you need to specify which one is used by which query. I'll come to that in a moment. So the unit is within that ORM tool what defines the external storage, the database, and then we need to define where the database is. And I think it's always the case that it always looks up the database as a GNDI resource. GNDI, for those that are not familiar with it, GNDI is kind of lookup mechanism within the within Java, in Java SE. Yes, even in Java SE, so in Java SE, where you say I give something a name, and this is my data source. The data source, which is more or less equal to a connection to the database. So you define then here, this unit will use that GNDI info so that the system can look up that info and gets the connection to your database. And you can define some other properties, configurations that does not have anything to do with the connection itself, for instance, and this is not something that you should do in production, just to be 100% sure that everyone gets it. Meaning that whenever you start your application, you drop your entire schema and you create again a new schema. That's of course not things that you should do in production. This is purely for this hello world kind of things, so that I every time start over with a fresh schema, and so that I ever saw something new. You can then define, for instance, it's creating the tables and fields. This command, I will show you some more about it in a moment. But you can also load default data. Again, I'm loading some in two tables in a company and employee table, some data, but that's again not the normal way how you do it in a real world situation. If for those real world scenarios, then first of all, what I always find best is that you keep the management of your database outside of your application, because sometimes your application is the only user of that schema of the database, but most of the time not. So I prefer to have that separately, and that you have separate processes and guidelines on how to install that database, how to update it, if there is, for instance, a new field or whatever, so that you keep it outside of here. There are solutions like, for example, you have the Flyway library that allows you to define, for instance, your SQL scripts that create your tables or update table with a new field, etc., to define it within your application. And then when your application starts, it checks, and that Flyway system checks if your database needs to be updated, yes or no, and does that on the fly. Those things work also nicely, but as I said, I try to avoid it and want to keep that outside. But again, that's personal preference, that's company policies probably, etc. What we need then, as we said, we need a mapping. We need a mapping saying this Java object corresponds to this table in the database, to the company table in the database. And we also define then that each property, for example, this name property matches the name property on the table, the field name, the field called name in the table. Theory, this is not really needed, because by default, every property within an entity is mapped, and the name of the property is also the name of the field. But I'm one of those guys which prefer explicit things instead of implied things, which are nice until you just decided to do something like this and forget to update your database table, and then it blows up, of course, unless you have something explicit like this saying, okay, this company name property in Java still maps to the field name. So again, preference, but I prefer to be explicit on what is included. If something does not need to be included, then it needs to be transient. Then that is ignored. Each as a requirement, not from the database, but from JPA, each table requires a primary key, and you need to have then a property that corresponds to that primary key by having you can have the column, but by also having the ID. And you also need to say how that ID is, that primary key is generated. Is that supplied by the developer? Is that generated like this by the database? And then if it's generated by the database, how it is generated. For instance, here I say it is generated by the database, by this generator, and that generator is a table generator. So I have a table. It's one of the options. Of course, several options. You can have sequences in Oracle or those kind of things. But here I have a table which has a field that keeps track of the last assigned number and assigns or creates new numbers if you insert new records. So I have that for employee. And here, here I can also have relations, so I can many employees in one company. That's how I try to memorize what, because you have two parts, and sometimes it's so I have always the first part is the class where you're in. So I have many employees which are linked to one company. So that means that I need to put many to one here, and then the column name within the database, because there you have the foreign key relation, and then you can use here the complete, not just the ID, but you can actually have the object here. So that's the mapping. We have done already parts of the configuration. There is one important thing missing about the configuration, is that where is my database? And with Payara Server, you can create a data source, connection pooling, etc. In that configuration phase. As I mentioned, install, configure, and run your application. But here you don't have that opportunity. You still need it, but you don't have that opportunity to do it manually through a command or whatever. So you need something else. You can use that post-boot command file. There you can still have that create connection pool statement, but actually there is a easier way in Payara Micro. It also works in Payara Server, but it is really nice for Payara Micro, and that's here. That's called a data source definition. It is not part of JPA, but it is part of the standard annotations that you can use in Jakarta. So it is not something specific for Payara Micro. There is, however, something specific that I used here, but here the definition itself is not Payara Micro. Remember that I said this is the GNDI name where the system will look it up. So no wonder that I say, well, I create a definition with that exact same name. And I'm using MySQL in this case. So yeah, rather old. I should update it to MySQL 8, but there you have more issues with connectivity because it's more restricted, it's more shielded off. So I'm still using the MySQL 5, but it does not matter. You say that this is the class of the that needs to be used from the JDBC driver. You see, that's a package from MySQL, so that is the JDBC driver. And that JDBC driver requires always at minimum 3 things, which is of course the URL where the database is available, your username, and your password. And now I'm coming to the Payara Micro specific functionality. I can read those values from MicroProfile config, which means that I have an easy way of externalize that configuration. And that's also the reason why this data source definition is so handy with Payara Micro, because you can just point to your MicroProfile config saying ds_URL, username and password. They will provide me that information. And since the data sources are mostly in connection pooling, I can also define here a connection pool. Here just hard-coded between at always 2 connections available at maximum 4. So this is something Payara Micro specific. So you cannot do this with other implementations like Wildfly or Open Liberty. So now we have all the config. The only thing that we need to do is, for instance, in the service is that we need to write those queries where we say, select me any company. So this is the class. Always remember that you need to write Java classes in the queries of GPA, of Hibernate. Don't use the table name, because then you will say, I cannot find the Java class. So this JPA is actually selecting Java objects from the cache. If it's not in the cache, it goes to load it from the database. You can select all, you can have queries. I'm going to show the employee one, that's an easier one for that. I can select a single company based on the value of the primary key, that's with find. And I can do, for instance, here query as, for instance, I can select all employees where the company, the ID of the company is this. So again, this is the property. You see, IntelliJ links me to the name here, to this one, and this is then the ID field in that company. So always use. I cannot stress enough, because a lot of people are struggling with that, and that because most of the time they are equal, but not always. So that's why I always stress on those things. So use the Java ones, and then you can use parameters like this. That's a placeholder that you can then specify here, that parameter is looked up here. So that's also a good way of these placeholders to avoid SQL security issues, because if you concat your query based on kind of things, what's happening, then you can have, of course, some security issues if you don't watch out and allow, for instance, anything what the end user specifies for your where class, like a company ID, which is called one point comma drop database. Then it might be that if you concat the data, that your database is dropped by just that query. Another thing that is important is you have always with the database transactions. If like inserts and updates are successful, then they need to be committed. You tell to the database, commit me these data that I have sent now. They are good, they are final. And within CDI, you do that with this transactional annotation. So that means that any method within that class, in this CDI class, because it's application scope, that at the end, so at the beginning, there is a transaction started, and at the end, there is a transaction commit. If there is no exception happening, if there is an exception happening, then it does automatically does a rollback. So we say to the database, is forget these data, it was not so good. This transactional is the simplified version of the EGB transaction support, where you have 4 different ways of defining it, where you have much more fine-grained things, and that's one of the outstanding topics still, that although you have transaction support within CDI, it's not as extensive as with EGB. That's also one of the reasons why EGB Lite is still there, because it's not at the same level. I think I have, here, and And the entity manager is the one which manages the entire ORM, the entire JPA system. So I can ask a query from that, etc. And I can inject that. But it's not with inject, it is with a specific annotation. I can inject that into my class, and then I can have that. An entity manager is, as you expect, a interface. And if I'm right, it here is on the name. So that's what I said. If you have multiple databases, then you need to specify which one it's going to use. For instance, so I can use this name test unit, and then it refers to this definition of my persistence unit. So if you have multiple, then you need to say that this employee service uses this database, or even if you have one service that accesses multiple databases at the same time, then you have something like this, of course, and then you have two different connections, two different systems for each database, one for each database. That's in a nutshell around the configuration. There are still a few things missing. Is how do we specify here these config, microprofile config ones? How do we add the JDBC driver to Payara Micro? But from our application, I think I covered everything from the configuration, how you do the mapping. Of course, it was all brief because probably JPA on itself is a 2-day course itself on its own. So if you need to explain everything, but the basics are here, so you can get started with this and look up more info if needed. Any question already about that for the moment, or go we to the next one, how we started up for and those missing pieces, then the JDBC driver and the config. So let's what's he asking for attention? No, not needed now. Let's start the database. I'm always using Docker for that because I find it so easy. You just start something and you can drop it without the need to install it locally. So I have started now my MySQL database, and I have here specified a default user, a default password. I've specified that it will be available on my local machine with the standard port at 3306, etc. So my database is up and running locally, so I can start up Payara Micro. And then you see that you have already a larger command to start it up. Two things that we need to specify. As I mentioned, we need two things. First of all, we need to add the JDBC driver. So this is the way that you can add additional jar files. So jar files that are not in your WAR file, but are needed by Payara Micro in this case to execute your application because it needs a JDBC driver to connect to your database. The add libs is then the possibility. Another possibility is, of course, that you just include this this jar file, this JDBC driver within your project. If you define it here as a dependency, not sure if we find this something. I see MySQL connector, so I can define it like this, and then it will be included in my WAR file, and it is also fine. That's another option. Both had pros and contra. I want to keep this, at least for this example, according to the Jakarta EE standards, that means it is independent of anything that you use. So it's independent of the database. The database is defined externally. In this case, I'm adding the correct JDBC driver on the fly to Payara Micro when it starts up. That's one thing. Second thing is that we will define some system properties. That's one way of, as you remember, of providing MicroProfile config values. And instead of defining those system properties, which might be a lot of them sometimes, with all that -d, etc., which is the standard Java way. So I should do that then. Guess here before it. Not going to try it out, but you should then do all those system properties on this place. Payara Micro allows you to define them in a file, where you just have some kind of property file saying this is the key, this is my value. When it starts up, in a quite early stage, it adds those values as actual system properties. You know, system properties can be defined within your application itself. That works then fine for Payara Micro, and for MicroProfile, they will be picked up later on. So I'm defining my URL, which is the MySQL. It's running on my local host, although it is Docker, it is on that port. This is the default one. I defined the database. If you remember here, that's my database, and username and password are all the same, because I don't want to put any sensitive info that I would like to use, just dummy values. And then the last thing is, of course, my WAR file. So with this command, I can do whatever I need to do for Payara Micro, meaning I'll start up my application. I add the JDBC driver, and I have also defined through that annotation. I'm going back again here for that annotation. I have also defined the GNDI one. So I have prepared my system to access the database, and that should all go fine. And then you see at startup, because it was too fast, I also set here, log me everything what Eclipse Link is doing. The Eclipse Link was the JPA implementation. So that means that I get here a lot of an error here. I hope that, because that is not an issue. Yeah, it's okay. So I have a lot of info here, which is most of the time not useful in production, but it can be if you start up. For instance, you see that it tried to drop my table. I said drop and recreate, so that drop failed because there was no table employee. So that's my exception here, but that's not an issue, because I also have my table creation somewhere. This is still the drop. This is the from that table where I use for the primary key generation. And then you see here, it is creating my table. It is creating the employee table. And how does it know what to create? Well, he based himself on what I've defined here in my mapping. So he knows that he needs to create a table, and he needs to have a field ID, which is of type long, and he then where is the company? Here's the companies. So he takes a big int for that. So if you want to do that yourself, if you say, well, big int is not good enough, or it's not good for long, because there are sometimes several possibilities, then yeah, as I said, you should not auto-create your structure. But you see, it does also the insert. So my entire system is ready, and I have a few endpoints available. JAX has endpoints. I did not cover them, but they are purely as you can expect from what you have seen the previous hours and days, and then you can, for instance, read your data from that database, and you see he gives you the correct answer. And because I set the logging level to finest, I get all the info what it is doing. For example, he executed this query select from that company table where ID is value 1. I can even get printed out the value of this parameter. So that's another option that you can configure so that it also prints out your parameters that he has assigned to those query values. So that's JPA. And for those who are not familiar with it, there were a few people who were not really familiar with Jakarta EE or whatever, then this could be a nice starter for if you ever want to do something like that. So because it gives you already all the bits and pieces, which are a few, so that you can get started. A question can be used only the stateless annotation for the service class instead of transactional plus application scope. Yes, that's possible. But there is then, the writer knows it, but there is then, of course, an important difference. Where was it? It was in the service. So we have a company service. This is CDI. So if you want to use EGB Lite, but as I said, start to be reluctant to be doing that, then you should have used this stateless. And then you have an EGB bean, which already since a long time ago, the CDI container can also resolve. So this inject here, will still work. So there is no difference. The only difference is that it is now an EGB bean, so that you have by default 2 functionalities on top of your POJO, 2 functionalities. One is your transaction support, and the second one is security. So although you don't specify anything, it does some basic check around security, which is, are you allowed to do this? Yes, because you did not specify any annotation, which means that that anyone can do it. So there is a small overhead for security, and there is one for transaction, but of course you won't hear transaction, so that's fine. Again, for that transaction, I always am very explicit. No, not mandatory. Required. I'm always explicit, saying that if a code piece calls one of these methods, then I need the transaction. It is required. So if it's not available already, so if no transaction is started, it creates a new one. If I know that, for example, from my logic, I'm not going to do it like this then, of course, but suppose that an insert, I know that it is always used as top level, so it is should always be the first part in a transaction, not new required new. The first thing in the transaction, and that there should not already be a transaction ongoing, then I say requires new, so that I know that if there anyhow this method is called as part of another transaction, that it is a separate transaction, so that it can be separately be committed or not. Again, that's my love for explicitly defining everything. because at the end I found out that most of the time those, okay, it's a bit more of work, but it clears up a lot of confusion which might arise, or in a larger complex application there might be so many calls, so many connections that you sometimes have the unexpected things that two actions end up in the same transaction and that they both failed unless, although one of them should be fine if they are separate. But yes, stateful comes in HB Bean. HB Lite has support for transactions, so that works also. Any other question? Going to restore it a bit. No question. That's fine, of course. If everything was clear, transaction was there for declaring it auto-commit. Yes. Auto-commit in the sense that just as with that EGB one, at the end of the method, there is a commit if there was no exception. Yes. Because auto-commit has another meaning. In terms of database, auto-commit means that from the moment that I do my insert, that it's already committed, but that's not the case. This transactional means that at the end of the method, there will be a commit performed. So it is not exactly the same as an auto commit in JDBC terms. So, but yeah, it does a commit at the end of the method, which is automatically committed, but it's not the same as auto commit. Sorry if I'm a bit picky on that, but yeah, terms are important, of course. No, the question is, if I have a transaction that has multiple statements, insert and update, then I have to avoid transactional annotation. Well, it depends. If you say I have multiple because I have multiple commands here. No, it's not update, of course. Merge, is it called? Then, yeah, it is fine, of course, to use that transactional, because then at the end, all of them are gone to the database or committed to the database. Of course, if I have several methods, if I have something else, again, it's not really useful. But if I do something here, and I can only have a commit when both of the methods are executed, then yes, transactional will not work, because the transaction will be committed here, and this one will be done in a separate transaction. So that's what I said. With EGB, you have much more control over that, because you can combine methods and say that they share the same transaction or not, and those kind of things. And with that requires new, required, and those kind of things. You have there, you have several options, but there you have much more flexibility, which you don't have here with the transactional. Next question you then might have: how do we do it then in this case? So then you need to get your, so don't use the annotation, that's one point, but explicitly ask for the transaction. And then you can say begin, and at the end you can say here commit. So then you need to resort to those kind of things that you explicitly say when a transaction needs to start and to end, and then you can combine these two methods in one and the same transaction, which is fine, but you see, it's a bit more of work. Question: is there a need to use the flush method with transactional, or are the loaded objects never stale due to the annotation? I'm not sure, then I misunderstood the transactional annotation. What does flush do? Maybe that's not entirely your question, but flush, as I mentioned, JPA is working on objects and a cache in memory. So if you say persist here, actually the insert statement to the database is not performed at this moment. It is only performed when it tries to commit or when you explicitly say flush. At that point, he generates that insert statement, and that insert statement will execute it, but of course the commit is still to come. What you probably are thinking about is I have my first level cache and my secondary level cache. My first level cache is here in that within a transaction, more or less. It's not exactly correct, but okay, let's, for simplicity's sake. So whenever I start here my transaction, I start a kind of cache. And every time I'm interacting with the persistence manager, I'm interacting with that cache. Since that's one single transaction, you cannot have something which is stale, which is not the same. It can be that the database has already something else. That is a possibility. Therefore, you probably need your secondary level cache, which is globally for your entire application. And then whenever there is in another thread, so outside of this method, when there is another thread which already does something with that, not inserting it, but updating that same company, what you are trying to do here, then your secondary cache is notified about that, and then you can have some kind of synchronization, but that's all internally within the JPA, within Eclipse Link. So actually JPA is a rather complex beast. But you still can have the issue, of course, that you are trying to update values which are no longer valid within the database, and then you get a database exception. So yeah, that's possible about it. But actually, that transactional, if you say, did I misunderstood it? Well, that transactional actually, what it does is that it does this through an interceptor. It does this at the beginning of your method, and it does a commit at the end of the message of the method. That's basically what transactional does, so that you don't need to write these 2 lines all the time. That's basically what it does. It does not influence how, what you mentioned there, that stale info, that is nothing related, that has nothing to do with that. Of course, with that transactional behind the scene, there is some synchronization between caches, etc. But yeah, I hope you get what I mean, that it is related but not related. So okay, good questions. Always good thing that I can learn a few things about this. That's the idea of trainings, of workshops. Any other question? Otherwise, we are ready for lunch. Okay, so important that data source definition, try to remember that. That's a nice thing, so that you can use the microprofile config, supply the JDBC driver to that adlibs, and then yeah, I've showed you the basic functionality of JPA. As I said, that will be a 2-day course on its own. I did that once before, so that's there are a lot of things in JPA. And after the lunch, then we start with the alternative, let's the microstream way, which simplifies things in a certain way, but it's also completely different. So I'll see you then in 1 hour. So 15 minutes after the hour, I start again for the second part of today, the second day. Enjoy your break. So welcome back, everyone. Hope you had a nice lunch break. Thinking about all the functionality that was presented already around microservices, Payara Micro, etc. We have a few things to cover. There is still room for questions and things which are not really on the agenda, but if there is enough, if there is some demand and I can quickly put something together, I still can handle a few things. Going to add a few things around, for example, Hazelcast and Docker images, which were a few questions during the last, so mainly yesterday, so the last training day. But first of all, we are going to discuss a bit MicroStream, what it is, what you can do with it and how you can use it. And yeah, the idea came from to start MicroStream, the code, the framework was around 10 years ago, where, as I mentioned with JPA, JPA works on selecting objects, but they are in a cache. If not found, then it's going to database, etc. So all the complexity around it, as I mentioned again, but it is a nice thing. It works, but sometimes you need to put quite a lot of effort in it and quite of tuning and etc. to make it really perform for the last until the last bit that you get out, that you can squeeze out it. So it is a rather difficult, large specification. Yeah, the idea is I'm reading object from a cache, I'm reading object from memory, but if that was the initial idea, then probably you can do something much easier where you consider your Java objects within the JVM itself as the database. And that means that you don't need any kind of SQL. You don't need any kind of additional query language. You don't need additional functionality, additional classes to get the data. Just access data through getters and Stream API, for example, for collections to search and filter and aggregate even. You have the grouping by, which is available within the Stream API. So for accessing data, Java is more than enough. It is also faster than the situation where you first need to check the cache, then need to create JDBC queries, call it, request the data externally from some database where you have the additional latency due to the network. You have the conversion because values in the database are more or less just strings and numbers. Okay, there is a few things more, but more or less just string and numbers. So you need to convert them anyway. So there is a lot of work. Why not just use the JVM? Why not just use the objects? You have, of course, one system, one problem that you need to solve is that, yeah, your JVM stops, your process stops, and your data is gone. So if you don't do anything, then you'll lose all the time all your data, which is, of course, a very bad thing. So that's the reason why then MicroStream created the storage manager, and that storage manager will store some data, some object graph, as they call it, at the root, starting from the root object, store Java objects in a binary format externally. That can be disk, that can be the cloud storage like Amazon S3 or the Azure storage system, etc. So that when your process starts up again, that storage manager can create your objects in memory again, as it was when you stopped it. So it is still available within memory, and again, fast access. That idea of storing it came from the idea of the system prevalence, for those maybe who have heard about it. And the idea of system prevalence is that you take some kind of snapshot from your running system, you store it externally, and then you can start from that snapshot again. There are some issues related to that system prevalence things, like, for instance, you need to store a massive amount if you store everything from your process. There are only snapshots, so in between you don't have that backup, let's call it that way. So MicroStream is storing only a limited amount of data from your JVM, so not everything, only that object graph that you indicate, and it stores it continuously in the sense that if you made a change and you say store me this, then it stores it just like you do an insert or an update saying database keep me this data. Then the storage manager can also store that in a binary format. So it is a completely different way of thinking around data storage. Mainly the main new thing is that it is no longer depending on something externally as the primary source. Of course, that binary data needs to be stored somewhere, but the primary source is your JVM itself, where you don't need anything special. Just getters, just stream maybe. There are, of course, also other challenges that you need to tackle. So it is not a silver bullet, but in some cases it can be a valid alternative for a database. Yeah, that's the traditional one. You have an object graph in your JVM, and then you store it in the database in another format, in another type of architectural type. You have the relational model and the object-oriented model within JVM. So you have what they called those impedance mismatches. You can have, you probably know them. You can look up on the internet to find more about it, what it exactly means, and how to know the details. But in general, you know those things, maybe not actively, not everyone actively, but I think it's easy to understand that you have some kind of mismatches in how data is used within the JVM as object and externally stored in tables with fields and rows. So what is then different with MicroStream and the MicroStream persistence is that with MicroStream you only have a rather small library that you add to your application. That's that blue layer in the image. So in the stack of the components, you have a small layer of MicroStream, which is responsible for creating that binary representation, loading it at startup time, etc. And yeah, that binaries can be stored then in just a plain file system in a directory. Later on, people said, well, we are paying for a database, which we are also using for other systems. So why don't you store those binaries as a blob in a database? Because then you have already solved the backup and that our database is backed up. So it also backs up the data, etc. So eventually you can store it in any system that accepts a binary. So that means event streaming systems like Kafka, cloud storage providers like S3 and Azure, etc. So it's pure a binary representation of your object graph, which greatly simplifies your architecture. You don't have that external system anymore. You don't have caches anymore. You have no more conversions, because okay, the binary to the in memory of Java is a conversion, but other than that, there is no conversion to a certain external system. You minimize latencies in most cases, because reading data is most of the time, or in several cases, already just accessing your JVM memory. So that is great for performance. And since it's a lot easier, it's also quicker to develop and easier to maintain, easier to debug than trying to probably tweak all those Hibernate queries so that they are more performant. So yeah, there are multiple systems, as mentioned. The databases, all typical databases are supported. NoSQL solutions like in-memory grids like Hazelcast. You have Redis, MongoDB, and those objects, cloud object storages like S3 and the Azure Blob storage. So you don't, plus disks, which are not mentioned here. So you have more than enough ways of store the data that suits you most, depending on the environment, in the cloud, locally, or if you have already a database and those kind of things. MicroStream itself is built up of several layers, and actually each layer and each subcomponent is a interface with a default implementation already available, which is also selected by default if you do not specify anything, which means it's also highly configurable, highly tweakable, tunable for your case, which requires probably more knowledge about it before you can do it. But it is, in that sense, a very flexible tool that you can manipulate for your own use case. And a few things which are important, for instance, that file system abstraction, that's called the AFS layer, abstract file system, and that is there then so that we can support all those different targets like disk databases, Kafka, etc. You have also what's called a file system. Well, a file garbage collector. File system is file system because it is a file system. But and why is that? Because when you save changes with MicroStream, you don't change all your object again over and over, because that can be large within your memory, and changing one little property of a class does not, of an instance, does not justify the saving of the entire object graph, of course. So we are only saving changes, the differences between the previous state. And all those little bits and pieces are grouped together if you start up. But for instance, if you have an object, a customer, for instance, with his name, and you update his name, then you have also that old version of your name still in that file storage, which ends up, if the storage only grows, then you end up with issues there. So there is it's also called the garbage collector. Everything what is no longer used is cleared out so that that storage is kept to a minimum. There is a question, I assume it's around that garbage collector. Can that used to be in some form of versioning, for example, roll back to a certain date? No, because as I mentioned, maybe just after you have typed in the question, the garbage collector removes obsolete data blocks. About serialization, for a rollback, yes, you can use the serialization to save something and then read it back. In one of the examples, I'm going to use the serialization. So yes, that's a possibility there that you can use it. It's not, I guess it's not the main goal of MicroStream, but you can use it in that way. Actually, only the serialization engine is needed for that, but I'll come to that in a moment. Because of there is a yeah, you have their data, but data is not fixed. Just as you change your database model, create another field, create another table, rename, refactor things. One of the things what is included within MicroStream is what's called a legacy type mapping, where you can address data model changes, evolution. That's also the reason why there is why not the standard JVM is used. The standard JVM serialization is not used, because we needed a system that is capable of changing property names, changing structures, etc. Because your data model evolves. That was one reason why there was this custom serialization. The other one is of course, because with the standard Java serialization, you always have the requirement of that interface implements serializable. And if you want to store any kind of data, any kind of JVM Java object, then you need to be able to store anything. So not only those classes that implement serializable, because maybe you're using a class from a third-party library that you include in your application, and for some reason it is within your object graph. There are many reasons for it, and if it's not implementing serializable, then yeah, then you have an issue because you could not use it in that case. So that are the two main reasons why there is a custom new serialization engine, and that's needs to serialize anything, and it needs to be able to evolve your data model. There are in total, like as I said, 20, maybe I did not say, but 20, 25 subsystems. Most of them you never want to change, need to change. So configuration can be simple. On the expert level, you can change basically anything that you like. Also good to know, of course, for us here now, there is a Java version of it, so that it works within any JVM. So it can also be combined with Kotlin, with Scala, Groovy, etc. But there is also a version for Android, so that you can store your data, for instance, when you're working with that what's called offline first scenario, that if you don't have always a connectivity to your server, that you store it data first locally through MicroStream on the device itself, and then later on synchronize when you have connection. So how does it work? A few basic demos. First of all, you need a dependency. As I said, it works entirely by adding a dependency in your project. And yeah, most of the time you just need these two. This one is the main one, which brings in a few transient ones. I will show you. And this one is required if you're using the typical configuration through a builder to make it easier, or that when you read the configuration from an external file where you read some configuration properties from a file, then you need this embedded configuration dependency also. This main one has a few transitive dependencies, but if you look at the list of my dependencies in the project, then you see that they are all microstream one. And that's deliberately in the sense that and we need some utility methods, string utility methods, whatever kind of utility methods. And it was explicitly the solution then to not include something like Apache Commons or Google Guave or whatever, because yeah, that can bring in some dependency conflicts. So if we are depending on a different version than you have that you need within or that you want to use in your application, then it might have a conflict and that might not work. So everything is really embedded, all code. We are not depending on some external library for that purpose. One exception, SLF4j for logging, so that when your application is running, that you see some either minimal by default on info level or very extensive debug info of what the system is doing. Then, but that's most of the time not a problem, because SLF4j is in that sense a really good library, because every 1.7 version is compatible to any other 1.7 version. So if you have, like here, I've added the just pure simple for output, but even if it was not the exactly same version, then that would not give an issue. So that's the reason, of course, that we did not invent our own logging system like some companies do. So that's the dependency that you need. And then what else than the hello world that we start. And first, maybe a word on the configuration. The configuration, you can, as I said, do a lot of the configuration, configure a lot of aspects, but there is two main things that you need to do. That is saying what is the root of your object graph that you want to manage with that storage manager. It's even better to just use it like this, because that's a higher interface which also contains everything. So the root that needs to be managed by the storage manager, and the location where we have that we have those binary data. That can be as simple as then one method where you start the storage manager with those two parameters, and everything else is default values. So what is your root object? Well, that is one class which contains or is part of your object graph, because an object graph is a linked set of objects. That can be or there can be circular parts in your object graph. Some people say that it's not really recommended to have circular references, but parent-child relations, for instance, sometimes it's easy to have on the parent a list of your child, and child has a link back to the parent. So for that reason, there must be a object that if you traverse all the links that there are, so all here there is now just one single string, but if you traverse the entire graph that is accessible from this one instance, then that's the database that you want to use and to manage by MicroStream. In the theoretical case, maybe that is sometimes the case. If you have two groups of objects, two object graphs, and you say, oh, I need them both, then just create one object where you link them, where you linked one of those objects of each graph, and then of course that the system can find everything again also. As I said, no implements serializer or whatever, no requirements on your class, no annotations, no nothing. It just scans your class structure to know what it is in there and saves what it is needed in that binary format. And the second thing is here, for example, where is it located? And I'm going to put in the target data, which I'm going to remove because otherwise you see all data. I've dropped my database by just saying delete that directory because everything of my serialized form of my database was in that directory. So when this starts up, there is some magic going on, more on that in a moment. So initially my database is empty, so you would expect that my string is NOLL. So initially I will print out my content at load that will be empty, but then I can set that string value with hello world with a timestamp. And then I can say to the storage manager, store me this object, store me the root, because yeah, the root is just a simple string there, so that's fine. And then I say at shutdown it was that, and then next time I start it up, there is some magic happening. But first let's run it, then the magic will be easier to explain. So initially the content was nothing. I set it hello world. That's my current time now. So that's stored in the data in that file here in the target data. Go into a bit more detail what it is in a moment. So if I start it up again, then there is that one magical thing that this start method, it's doing a lot of things. But one of the things is that it analyzes what's in that directory. And in this case, it sees that there is a block, a data block, a binary data block for this data root. And instead of the initial value that we have assigned to it, then it overrides it with the data which is found here externally, which means the data that we have saved in the previous run. And that's the bit of magic what is happening there, because somehow it overrides it, and with somehow I specifically say somehow because there is some special tricks going on, because we are not using the constructor of the objects and we are not using these setters for setting the values. To make it secure and safe, the data is directly put into the JVM heap, so bypassing all constructors. So we are just pushing things in address spaces, and then we put that pointer into the property that of your object. For instance, we put the correct location of that value here in this value property. All those things are done because we want to make sure that you do not have any security issues if someone tampers with your structure, with your binary data, as you can have with the standard JVM serialization. Now you can define some filters since JDK 17 to avoid those kind of things. But if someone would somehow be able to modify this binary data, then that you don't load any kind of class and execute the constructors or those load methods which are executed by the standard JVM, and that you can have those what's called security gadget change, and that you have security vulnerability. So that's not possible because we are entirely bypassing constructors and setters, pushing things straight into the JVM heap. How it is stored? Well, once that's binary formatted, so you don't see a lot of you cannot make a lot of sense out of it. Besides that binary format, there is also this file, which is called the persistence type directory, type directory in short. which which defines what that binary data actually is, because in that binary data we only have unique identifier numbers like this one, and we have those data blocks, for instance, like a string. Then we have an array of characters, but this unique number here says then, okay, we know that this is so this type ID corresponds to that object that we have here. If I'm creating, just for fun thing, if I'm creating a new property and I can just run it again, it will, okay, it's not even printed out. But the microstream will see, oh, at some point there was a data root with only one string called value, and now you also encountered a data root with a value and new property, and that's something else that gets a new number assigned. So this unique number is not for a class, but is for a version of a class. So as you can see, that opens the door for data model evolutions, so that you can have data in your binary format, which is for either one class, the old version, or either the new version. And that can be even mixed and matched, and everything will be mapped against the actual class that he sees here. That's in short the hello world thing. Maybe there are already some questions, because yeah, this is probably new for a lot of people. So if you have questions. So what is then, this is the hello world style of configuration, which is, in, I think 99% of the cases not used in production. There you have more this kind of builder type of configuration. And that requires that additional dependency here, where you can specify properties like that. Again, where is the directory? But you can also define a channel count. What is a channel? You see here we had one channel in the simplest case. And its channel corresponds internally with a thread. So if I say I need 4 threads, then yeah, there are 4 threads created, and the storage manager divides the work between those 4 threads, between those 4 channels. So that means processing is improved, and that channel, that thread, is responsible for 2 things. One is doing the conversion from object to binary and from binary to objects again. So what's called the serialization engine is running inside a thread. And once the binary data are there, then that same thread, that same channel, is responsible for pushing it out to your storage, in this case to disk. So it is using the non-blocking file IO in this case to write it out. Okay, there is a question around, does it matter if a class has a more complex property like an input stream or an injected property like persistence context? I will ask that. I will answer that in a moment. But yes, it is important in some sense. So these are the standards. You have several of them. You can define, for instance, the the maximum file that this file can grow until a new file is defined. You can define those prefix names, the suffix, etc. So you can basically define and change every little aspect of it. Or you can use through another, it's not a builder, then through another loader system, and you can also do loader. You can load these properties from a property file or an XML file, so that instead of getting these individual configuration values from an external system like MicroProfile config or whatever, then you can delegate everything to a certain system, and then you can load it from a property file. I'll talk more about that integration and loading properties with the CDI integration that was also created for MicroStream, and that can also be used with Payara Micro in a moment. Once you have set the, let's call it a simple configuration, then you create what's called a storage foundation out of it. A storage foundation contains then the final configuration, not only those simple ones, but also all those, as I mentioned, all those default implementations of all those interfaces. And then you have the chance to change the default implementations, adapt them, configure them in some cases, etc. So this foundation is very large, actually, because it has all the options to configure it. One of the things that you need to define then on that foundation is to set the root. And then when that is all done, you can create that storage manager. Again, well, this was created when it was not working that long for MicroStream, so that's still not the optimal version. So when you have then that storage manager, you have to start it. There is an explicitly start required, otherwise it does not work. And at this moment at start, then you have again this root that is populated. And in this case, it is a list of products where each product is just ID, name, and enum value. And then you can see if there the content of our database. If there is nothing as in the beginning, then I load some products in that memory object, that JVM object, and I store. And then there is the rule, store what is changed. What is changed here? Well, I added some products to this list. So what do I need to store? I need to store the error list. And then system will figure it out, which items were there before, which are added, which are removed, etc. So what all the changes, then it stores only those changes in that binary format. This is, for example, then a way of querying data. You probably know it, just Stream API. Most of you know it. If not, you can look it up, how it works. So you stream a collection, you can do filter, you can do manipulations on it. You can convert items from one type to another in that stream, etc. So that's our query language. So nothing specific for that from MicroStream. So if just loading it. So the first time it is empty, there is nothing. It will load those X number of products. How many was it? 4 numbers of products. So at shutdown, there were 4 numbers, 4 products. When I started up again, then Those 4 are loaded and they are here printed out. So the magic happened and it is restored. So the question was does it matter what's in my object graph? Can I store anything? Well, yes, the idea is that you can store anything, but there are a few exceptions. And I guess you know that the examples that you gave there in your comment, like input stream and persistent context, are a little bit of special things. One of the other special object, for instance, is thread. I can have a variable thread here. I can indeed have here an input stream. I could also put here the persistence context, but of course I don't have that dependency here, so it will be in red anyway. ID, well, for some there are explicitly within the code mentioning that sorry, I cannot store this, and you get an exception. Why you get an exception? For instance, this thread, but also this input stream, they are having a reference to some resources, as they call it, a resource to a file, a socket for connecting to a certain port, has a resource to some operating system resources. Which means that if you restore the data back from that binary format, that those resources are not opened for certain as it was when you have stored it in that binary format. So for many of them, I like thread. I also think input stream, but I'm not 100% sure. Then you will get already an error saying if the system tries to store this as part of the root. How can you avoid that error, but still have the object there, the properties there, so that you can initialize it and keep it there if you need it, then by just putting it as transient, just as the standard Java serialization, everything which is declared as transient will be ignored. So the general rule here also is if there are some operating system things related to, like threads, files, persistent context, has also a lot of references to outside things like persistence context and connection to a JDBC pool and connections, etc. So all those things cannot be used. Is that an issue? Well, I don't think so, because the main goal of your object graph and what needs to be stored within your database or considered as your database are data. This is not really data. By the way, a runnable, which is very closely related to a thread, that is possible to store. So depending on the level, you cannot store it, but most of the time it is also because it is not really 100% data related. So your object graph should be data related, or otherwise, if not, you should have a transient keyword there. So this builder configuration is the this is the really the normal way to, where is it here at the bottom, or you can use an external property files. Now, next important question before I get it in the chat is, well, I have millions of records. I have a very large database. Am I supposed to put everything in the memory before I can use it? No, you don't need to store everything all the ways into memory. We have a functionality which is or a class which is called lazy. And lazy acts like a kind of proxy. That means that when lazy is part of your root, so this is my root again in this example, and I have here an object like string, I have here a lazy and a lazy list of strings. And if MicroStream finds this when it reads the data, then it's not loading that list into memory, it's only loading this lazy object into memory, which then acts like a kind of proxy. So whenever you call the get method on that lazy instance, then at that moment it is loading the data from your external storage. Which of course takes a bit of time, but that avoids the fact that you need to put gigabyte of data into your memory all the time. Okay, once it is in your memory, then stays it there forever? No, because this lazy, it's an interface, the implementation itself is based on what's known in Java as weak references. Weak references are garbage collected by the garbage collector whenever there is a memory issue. So suppose that you are nicely using those lazy reference and you load data and load data and load data, but at some point your memory can still be full. At that point, the garbage collector kicks in and he sees that those are weak references and he just throws out that memory. But it does not throw out the proxy, of course. So you can still use the get next time and it loads it again. So that's already nice. But you don't need to wait until the garbage selection say, emergency, there is a problem, we need to urgently clear out memory. You can, of course, help the garbage collector by already saying upfront, okay, I did a get on that object, I have used that list of data, and now I'm done with it and I don't need it anymore, so I clear it out. From that point on, that weak reference becomes a not used reference anymore within Java, and then it is a normal object, and the garbage collector can even clear it out before there is a memory issue. So it can clean it up as a object, just like any other object, which is ready to be garbage collected. So with this clear, you already say to the system, go ahead, I don't need it anymore. There is also another functionality within MicroStream that says that's the garbage collector, the memory garbage collector. No, that's another thing. You have the lazy reference manager, and the lazy reference manager. You can configure that any kind of lazy object which is not accessed in the last X amount of time automatically mark it as clear, mark it as no longer used, because there is some bookkeeping done around those lazy ones, and that lazy reference manager can then say, oh, you did not use this lazy object since 4 hours, for example. The last access was 4 hours ago. You have that through that last touch here. It is still loaded, so the data actual are still in memory. You did not. My threshold that you configured as developer is 2 hours, so already perform that clear so that it can be removed. So that is a way that you can help the system by not relying on the actual panic reaction of the garbage collector, which throws out actual weak references which are still there. So that's helpful. So how? So I think it's the functionality is clear. So you can use that in of course in several ways. Like here, which is not just a demo. It's not the most common way, where you in the root don't load that that list of strings here unless you explicitly access it through that get method. But there are other more interesting use cases, and that is actually for splitting up large collections. So suppose that you have a list of all the orders for all your customers, which can be, of course, millions of items, 10 millions, hundreds of millions of items. I don't know, because you're a large company that's doing a lot of orders. So does it make sense to have them all the time in memory? No, not at all, of course. So this is then a kind of indexing way. The same as you define indexes, well, not the same, but similar than you define indexes in a database. You can define, for example, a map where this is the customer ID, for example. And so for each customer, you have in that map a lazy list of orders. So that means that whenever you start up your application with the storage manager, it does not load all the orders. Actually, he loads only the map values with the key value pairs, but the values here are the proxy. So whenever then you say, okay, give me all the orders for that one customer, then you can do orders by customers, the get from the map here. You ask for a certain customer, and then this is the get from the lazy. So at that point, you have your list of orders loaded on demand. And you probably need to keep this reference then, because then you can call .clear. You can clear out your proxy so that you make the data ready to be garbage collected. But probably you also want to have that same list, those same orders for the last month or something, not by customer, but by month. So then this, so you have each order as once in a list for the customer, and you have also the order once in the list for the month-year combination, for example. That allows you to get, for instance, if you want to have a specific, a list of orders for a specific month, that allows you to access these data, again, limited, and you don't need to loop over all your customers, filter out each of that month, etc. You immediately have those orders for that specific month. And of course, what you put here as an index value, that's just as with a database, it depends on your use case. I hope I made it clear that you can have different ways. Yeah, even with this lazy loading, it's not with this query of 3 tables. It was a more complex one, but you can achieve even with this lazy loading. So that means that you need to load data on demand. So not everything is memory. You can easily achieve a performance, an execution time which is 100 to 1,000 times smaller than with JPA and an external database. So it is a very performant system of where you can handle data, you can fine-tune, you can clearly indicates how you want to access your data, how you want to group your data, etc., etc. Okay, another good question. Are there any issues regarding concurrency if multiple JVMs use the same storage on the file system? Can I declare transactions or read-write logs? Well, first of all, by default, the open source version has the limitation that you can only link one JVM with one data storage. For the simple reason, if you have two JVMs, then they don't know each other and they just write to the storage and they actually are blocking each other or conflicting each other, and you end up with a binary system here, that binary file system that is either corrupt because you're accessing it from two JVMs at the same time, just as you access one single file from two JVMs itself. That's also problematic. Or in the best way, you have data from a mixed system and it's not the actual representation of what happens in memory. So yes, there is an issue. There is an enterprise version where it is possible. So if that is the case, you should contact the people from MicroStream to know more about it. But there is another thing around concurrency, which not everyone thinks about immediately. Going back to this one, although it is a bit too simplistic. Let's go back to this one. This data storage, so there is only one instance of that object, or there should only be one instance, which have a list. So what happens if I read and write at the same time? And that's then regarding your question, do we need atomic variables for multi-threading? Same thing, the same question you can ask, what happens if I'm reading this list at the same time when I'm changing the list? Yeah. So, but that's not different than with any other what's called shared instance between multiple threads. So you need to do that also outside of MicroStream. So what do you need? You need to indeed to protect that you are changing your object while you're writing, at least if you want to have some consistency. So atomic variables you have, for instance, for those who are not aware of it, you have something like an atomic long. I can give it an initial value, that's not important. And then you can do something like counter, get an increment, or the other way around, which is thread safe. So this is safe if you access it from multiple threads at the same time. If you want to have a protection between the get method and the add method, then you could, for example, that's a very rough system, then you can use, for example, that synchronized, and you can define here a product log, for instance. I'll come to that in a moment. And I'm probably need then to create a new one, because otherwise it's still not really protected, because I'm just getting the reference back, and I need the same thing for here also. And my product log is something like an object. So this is the way how you can make sure that produce the non-final. Yeah, of course. Thank you, IntelliJ. This needs to be final before it actually works as a real log. So this way I can protect that two threads access these statements at the same time, which is very rough, of course, because that means that also two threads which are just reading are blocking each other. So they are just waiting to each other. So if you want to do a more fine-grained control, then you need to use like the read-write re-entrant, not read-write lock, but read-write re-entrant, or is it an re-entrant read-write locks? These are then, that's more advanced concurrency within Java, but have a look, there are some nice tutorials on it. So with that, you can, for example, make sure that as many reads as you want can happen at the same time. But if there is one write which tries to, on the write lock, if here one thread wants to use that write lock, then it waits until all the reads are done, then that write is performed, and only one write at a time can be done, and all the reads need to wait until that write is done. So that's the most advanced locking mechanism in Java, at least for that type of thing. That synchronized one is a simple, but yeah, most cases it will not be the most efficient one. So yes, MicroStream is relying on pure Java mechanisms. So that means that it also, this storage is a shared resource between multiple threads, which means that you need to protect it properly through concurrency mechanisms. And the open source version has a limitation that you only have one JVM linked to one storage. Any other question? The question is from Oliver. I'm thinking about using the storage for cases when runtime exceptions happen during production. The idea is to replicate the scenario on a testing system to search for the cases of whatever happened. Is that a reasonable use case, or would that be overkill? It seems very helpful to have the object graph during debugging to figure out what happened. Not sure I have the complete picture because it's already quite advanced one. Do you mean exceptions that happen during runtime for a normal database, or exceptions here with MicroStream? That's one thing. And scenario on testing the system to search for the causes of whatever happens during those exceptions. Yeah, I see what you mean more or less, but at least something happened, I don't know what, so I want to import the data storage into another JVM for debugging purposes. There is the possibility on the storage manager. Let's, for instance, here I have a storage manager. You have the possibility in the storage manager to perform issue a full backup. So if you have some kind of exception handling and a central place, at that point, you can, for instance, issue a full backup to a certain directory so that you have the data as it was during the time that your exception happened. But I need to warn you, if you have 100 gigabytes of data in your total data storage, then you have 100 gigabytes of backup. And not any kind of exception will be usable, in the sense that if you have an exception because there is something with the storage manager going on, whatever that may be the reason, then a full backup on that same object where an exception occurred might result in another exception. So this backup might fail, of course. If it's, of course, not related to the storage manager itself, then that will not be an issue. But it is indeed a nice idea to have a complete, let's call it, snapshot of your data during the time that happened. And if you then even, for instance, in REST endpoints also log which request resulted in that error, that might be nice for post-mortem stuff, but it's already real advanced stuff, but in theory it should work in most cases. I'm not going to say that it is working in all cases. So I guess I'm too motivated to do everything with the data storage. Yeah, maybe, but I find it a really nice thing what you're thinking about, because in theory, what you mentioned, it is it's not that impossible, but other questions. Always love these kind of things, because you see people come up with scenarios what you never think about yourself, because yeah, you all have different experiences, different not so good experience with some kind of systems, and that you try to debug but never find out why it happened, because you cannot reproduce the exact same situation when it happens. So that's basic of MicroStream. There are three main things that you need to know. That is, how do you configure it? The hello world, how do you configure it? That root object. That's how to store it. That data model evolution, which I'm not going to in detail now because we don't have that much time. Lazy one is an important one. I think every 2 to 3 months there is a MicroStream training day. They always announce some free codes, so if you want to do, they are also coming from JAVAPRO, but it is at the end of the year, so I'm not sure if the trainings for the beginning of 2023 are announced yet. No, you see it ends at the end of December, so there is no more MicroStream's basic training planned anymore, but I guess watch out either this page or blogs, social media, whatever. There will be announcements of a new 2 days training sessions about Payara, about MicroStream. So if you're interested to learn about it more. One thing, since you have that serialization engine there, you can use that serialization engine on its own. So you don't need to use the entire system. In that case, you need this main dependency, then basically you can forget the other ones, but okay, I keep them here, of course. You need this binary persistence dependency for the serialization. It is depending pure on, because you see there is here one, but it is rather small. It is using the other dependencies, which you can use to create a binary representation of a certain object graph. You can store it, you can you can do basically whatever you want, and then you can deserialize it again. This as an alternative for the standard JVM. Why? Because the two things, then mainly three things what I mentioned before. You don't need that implement serializable with MicroStream. You even have with this serialization the possibility to do some kind of data model evolution. So the class structure doesn't need to be exactly the same when you read it back again than it was at the time that you created it. And third time, it is more secure. You don't have those security issues. So I have here an object graph. Actually, that's then an object graph with circular dependencies, because you have a boss which has 3 employees as the child of the boss, the parent-child relation. But of course, each employee has also a link to the boss himself again. So I have here a nicely circular dependency. I can ask for that serialization foundation, and it is best that you define the classes that you're going to, as not these string type things, but classes that you define. So it is easier that if you do, it's better performance, and sometimes you can have issues if you don't type them, don't specify them, that you have the classes here. So that's an employee one. I serialize it to a set of bytes, and I deserialize it, and I can print it. Again. So then it's probably no surprise. This was the original one where you have the employees, where you have the people who directly report to him, with only X and Y. The Z is a direct report of the person Y. And I also printed out the pointers that we use internally that you can use also. What is that pointer? That is, it's not here, it's in the employee. You can ask the system identity hash code, which is a unique kind of pointer which does not change even if the garbage collector moves your object around in memory. It's still the same pointer. So that's also used by MicroStream to see if that object is still the same, or if you have changed, for instance, the name of your customer, and you see that there are completely different pointers. Are the object the same? So if we test the equality, where we test equality, then it says, of course, no. If we test the equals methods, if we have properly implemented or not, yeah, I have properly implemented, so I can quickly add that. So are the objects the same, or are the object equals? Then you will see that it says true. So we of course can get our data back with the same data, but there are actually different objects in memory. That's the point of this little exercise, and also how you can use it. See, equals is true, but they are actually different objects, different pointers. Then a bit on how can you use it within Payara Micro, unless there is a question, but because we have a CDI integration. A CDI integration which brings in all the MicroStream dependencies, so they are nicely as defined as transitive dependencies. So you only need to say, I'm using CDI integration, that version, and you can bring it in, for instance, in those MicroProfile, a project with MicroProfile, just as we did earlier on. What does this integration brings you? First of all, it allows you to define those configuration values, as I said before, that we use there in the builder, instead of hard coding them, of doing something yourself, etc. Here they are linked with MicroProfile config. So it's not only CDI, it also requires MicroProfile config, but Payara Micro has them, so no problem. So that storage directory, so the location and the channel count is coming from, this case, MicroProfile config file. I'm going to, no, I don't need to delete it. It's somewhere else. So that's one thing. So you can use whatever You can environment, you can use those system property files that we used for JPA. All those things can be used to retrieve some properties from that source for MicroStream. Second thing, what it brings you is that you can declarative define your root. So basically, the entire configuration goes out of your application. So indicating for MicroStream what is now your root object is done by this at storage annotation. So you see it comes from MicroStream integration. So this is also scanned by CDI, and we can tap in that scanning. And when we create our storage manager, which is then also done behind the scenes, is where, for instance, also here injected as a persister. So that's part of the storage manager that's only responsible for reading and writing data. But did I? No, I did not use it. But for instance, you can also inject, for instance, here, if you want to have access to the storage manager, you can just say storage inject me the storage manager. This is then this storage manager, the actual storage manager. This is an interface, but so the actual storage manager has become a CDI bean, completely configured with the values that you have defined here. That it means it can inject it, and this root is then linked with that storage manager. And as you see here, that that root, that class indicated as a root is also available as CDI bean. So you can now inject everywhere either the storage manager or either your root object, which means that here in this repository, I'm going to remove this again, within this repository, then you can access your root object and you can manipulate your data. Again, I did not put here the concurrency thing, so that's something that you should not forget. In the real world one, this demo, it's fine. There are two additional things. So this is the declarative programmation, the declarative configuration with the latest version 7.1, but it's not demonstrated here. You also have a possibility to customize that configuration foundation there, where I said that you can change all bits and pieces. You now also have a possibility to do that, but it's not indicated here. So that was in a nutshell MicroStream. Do I have more things about it? No. Any more questions around it? Or if not, you can, of course, look at the website examples, ask questions to the team. We are using the GitHub repo, GitHub MicroStream. So you can use here the discussion if you have questions, or you can use Stack Overflow with the tag MicroStream if you have questions. I see that there is a question that I need to. Oh, it is already answered. Okay. So if no more questions around the topic, then I think we can continue with the next one, which is integration testing. And we are back again to Payara Micro, Jakarta EE in general. And testing microservices is challenging. Integration testing in general is challenging. I make only distinction between unit testing and integration testing, although there are 4 or 5 different types of testing. With unit testing, you can just test a single unit, a single method, which means you test if I specify this amount of parameters on my method, I get this kind of result back from my method. That's, for me, that's unit testing. Integration testing comes at a point where you need something more in order to have your method to return a result. And that can be that you have, for instance, the examples that we had with that REST client that you call another another service. So how can you do that with integration testing? How can you do that with Jakarta? Because you need those external components, they need to be or mocks for that component, so not real stuff. Probably, how can they be in a consistent state? Like, for instance, a database. How, if you are testing the database, how can I make sure that for my test, the database has exactly those values that I am expecting to be in the database, and so that I can test if it's really doing what it is supposed to do in my test, etc. For test containers, so with test containers, that becomes a little bit easier. I'm not saying that all the problems are gone from integration testing, but you have at least a framework to have multiple dependent services and in a repeatable state, because just as you have seen with that JPA, I can just launch a container which contains my MySQL. I can initialize some data and I know it is there. At the end of my test, I can just drop it again and start it over again the next time. So that is much easier. So it is more repeatable with something like test containers. And maybe I'm assuming that everyone knows test containers, but the idea is that with test containers is that you're performing your tests by running processes. And one of the things is that your application itself and your dependencies, your services that you are needing for a certain response, that all of those are running as a container within Docker or these kind of things. And your test itself still runs locally within your JVM and is accessing these containers. Good. It's not open yet. So open integration testing. How can you do integration testing with test containers and Payara Micro? And maybe there is still easier ways than doing it pure with test containers, because test containers is, as it said, it's a framework. So maybe you should do some things on top of it. So you see there is now already lots more here, and for the sake of testing something more real, I'm having that integration testing, including that microstream CDI integration. So what do I need? Well, I need then JUnit 5, for instance, for the testing itself, assertions to test to see if for fluently testing my assumptions, what are tested, test containers itself. And there is a Java client and for test containers, so that you can create, for instance, images on the fly, launch them on a Docker system, etc., etc. And then you have the integration with JUnit, because test containers can be used with multiple test systems. So I need to have the glue between test containers and JUnit 5. And these are then my addition to make it even more easier, but more on that in a moment. Again, I have that same, I think it's the same application as the MicroStream CDI integration one. So I have a product here and endpoints, a repository with my inventory. I have that. I have those endpoints. I have that at storage, etc. So I want to test if I call that endpoint, those endpoints, to get all, or if I insert, then if that works, yes or no. So integration testing is, yeah, in most purest form, is really testing just the outside, interacting with the outside, just as users are doing it, and then see if that works as expected. So you start with a exact known beginning state. You perform one action, and you see if that changed that initial state to whatever it should be, whatever action should be performed. So how can I test that? This is the main one. So I have an integration test. This is the add test container. So the annotation, it's a JUnit 5 extension. So that means that this is a test. So with some additional things, that it looks for fields annotated like this, so that it knows which container needs to be created when you start your test. In this case, we need a, and I come to Docker in a moment with Payara Micro. So this container needs the official image for JDK 11 of Payara Micro, the version that we were using these 2 days. We need to indicate that Payara Micro runs on port 8080, so that we can access the endpoints from our test. We are deploying our application. So how is that done? So yeah, this is just a WAR file. So this project creates a WAR file. So I have in my target a myservices.war file. And I create that as a mountable file. That's also something from test containers. Yes, there it is. So that I can mount that dynamically into my image here. So I say that my service.var here is actually mapped into the container into this location. This is a special, in that sense, special directory that it is also scanned automatically by default when Payara Micro starts up to see if there is anything in that directory. But to be 100% sure, I'm saying that at startup, I'm giving these parameters. It needs to deploy this WAR file, which is actually my service WAR file, so the application that I want to test. And we need to tell test containers to a way to know when our container is ready to receive requests. The health endpoint is there, very useful. And as I mentioned, that health point gives the status up when your application is completely deployed. So I'm then reusing that MicroProfile health endpoint for Payara Micro to tell test containers, hey, this container is ready for some requests. So that would be nice. And then the next thing is that you need to call that product controller, that for instance, that insert or that get all. But yeah, then how can you call that endpoint? You have, of course, pure Java ways of to do. You have the URL, you have HTTP clients, etc. But let's go back to what we have seen. Remember that MicroProfile REST client that we can just model our endpoint, and that it then becomes quite easy to call it. So I have modeled my controller here, which is basically just copy and pasting all the method definitions in this interface. Still have the same annotation, so that's okay. It's copy and paste. There is even a way that you can share this with your actual code, but that's another thing. So when I can have a MicroProfile REST client implementation of this interface, I can just call insert in my test method and give it a product, and I know that it should call the real endpoint here. That's, of course, much easier. And that is exactly what I have done by this setup method, where I create a URI. So that's the, I remember that you need to configure for MicroProfile REST client where the host is. Well, I'm configuring it by, okay, using localhost because it is that my Docker client is running locally. The port is automatically assigned by test containers. So I need to ask test containers, what is a port that you have assigned to that port 8080 on which Payara Micro is running, and then I have that. And then I can use here that REST client builder, that's the programmatic way, which I did not show, but you also have a programmatic way. So I say, create me for this interface, create me a proxy. This is the URL from the location. And please also add JSON support because I'm using JSON, of course, as communication. And then I have a service here, a service where I can just call get all, insert, and all the other methods that I might have defined. One additional thing is that I like to see what happens within the container. So what I'm doing with this command here is that I'm mapping the output of Payara Micro within the container. I'm mapping that to the output of my JUnit test. So whenever I run that unit test, I will see, I might see some output from my test here itself, but I also see the Payara Micro log within the container, which is, of course, nice when things go wrong. And this is a test like no other test. It's just calling methods, see that initially there is no methods, there is no product because my initial database is empty with MicroStream. Also, I insert one product, I get back. I again ask for get all, and I see if then I have one product with which is equal to the one that I inserted. Run. I have Docker running here. So again, I have here Docker running. Let's go for the dashboard. And then you will see that it creates two containers. One is one container which keeps an eye on all the rest. And here is my Payara Micro running, you see. and then it's running, and after some time it started up, and I can call my endpoints, and still running. Integration testings are always slow, as you know. It's not the most, and it is green, so it was successful. Not because I did not test enough and I always get something green. No, I actually called my application in the container. And as I mentioned, here is my output from Payara Micro, also within my log. You can see here, that's the typical thing that you see within the output. So I have all the things that I need to write those things. Nice. But you see, there is quite some things to do. You need to define here all this. Yeah, I am not a fan of all those copy paste stuff then and reusing and things like that. So in this case, I already created something to help me, which is a custom container for Payara Micro. So I'm using that generic container from test containers, and I'm creating then this container here, where I already put all those things which I otherwise always need to copy over and over. I'm taking that WAR file as a mountable thing, but I have here another nice little thing. I can do a debug, because I can easily do a remote debug now. So if I have that parameter, I can do a remote debug, and I'm going to do that just because it is. Oh, I have, you see, I have already breakpoints, so I have already planned for it. That helps me already, because now my integration test, and I need to change this to true before it's debug. I only need to define the WAR file. Okay, that's only once. I can just say Payara Micro. I still have to do this. So that's probably another round of simplification, and I come to that in a moment. My test is identical. I have already, that's only here, the unnamed. The unnamed is, let's show here, the is just a remote debug looking to the same port than I configured there. So if I'm running my test, then I'm going to run the debug test, of course, like this, run. First of all, of course, my container needs to be created and started, but once it is there, then it is waiting. It will be waiting until I connect with my remote debugger. From that point on, it continues. So from now on, Payara Micro continues to starts up my application, and my test is going to be executed. And if everything goes well, and there's always a thrilling moment, is it going to stop my debugger, yes or no? On that point where I set it, it should wait, and there it is. This makes integration testing a lot easier, because now you can actually, in an easy way, tap into your program and see what's happening, and follow step by step what it is doing, if it's correct or not, and where the error is that you made. Okay, questions? I still have one step more to well, not to really show, but to mention. Any questions about integration testing? Test containers, what I did, etc. Okay, I hope you find this useful, this kind of things. It is there, again, it is available on that GitHub. I will show it to you for those who did not, for instance, downloaded it. So that integration testing, if you want to check it out, you need the Docker client for that, of course. Demos, integration testing, here it is. That's the project that I did run. As I said, you still have some boilerplate to do here. For instance, for that REST client builder, you need to add, and that was the other thing what I skipped here, you have to add things like Apache CXF, the REST client of Apache CXF. For that, you need a JSON provider, blah, blah, blah. So you need to do quite some setup. This is for that logging. So yeah, it is a bit of work. So I was working then already for a long time, but I finalized it under my company name @bash, integration testing. There are all the GitHub ones. I want to have the blog. I immediately jump to edit because I'm admin, of course, of the blog. So that you can more easily say, for instance, that you can write your test more easily. For example, that the same test that you saw before, instead of test containers, you can just say container integration test, which is something of the framework that I created. As you say, use Payara Micro, because you can use it with Wildfly or Liberty, whatever. And again, you just say, inject me here a REST client, the same interface that we have done, and then we can just do the test. So all the other boilerplate things that we have there in the project that I showed you are completely gone, are completely handled by that framework. And you can also do testing. You just say the debug is true, and then you can have those testing. You can do live logging. If not, then the logging is not done. And you can find it here in GitHub. I will just point you to the GitHub location. You can just add this per project, and then you have all those features available. Even you can use Wirebug to define the result of some remote services that you want to mock. So that's an easy way of integration testing. If there are no questions, then we have a 10 minutes break or so, not too much, because I need to cover the special requests then. So if there are no questions, yeah, the challenge, I will explain it, but I will cover Hazelcast, and I will cover Docker a bit more after our 10 minutes break. So 10 minutes after the hour, we start with the last block of the training. So the last bits and pieces, mainly on request, on demand. Let's call this a Q&A section of the training. Yeah, first of all, there was the question of Frank just at the end of the previous block, just before the break. Is Micronaut, can you use Micronaut in combination with Payara Micro? Yeah, actually no, because Micronaut itself is a complete product. It's not Jakarta compliant in the sense it does not it does not run against all the tests for the web profile, for example. Probably with this core profile, which is now new in Jakarta E10, they will apply for core profile compliance because they are having the the JAXRS, the CDI, etc. They are also working on that OpenDI, the CDI Lite version. So it is a product on its own with its, I would say, its own way of working, which is not a bad way, but is completely different than Jakarta. It is using JAXRS, for example, but it is also using other things. It is using also other ways of working, so that you can, for example, native compile, do a native compilation of your application with Micronaut. So it is a product on its own, so it's not possible to integrate it with something else, saying that, oh, I'm going to use half of Payara Micro and half of Micronaut. That's not possible from the Micronaut side, and that's also not possible from the Payara Micro side. So no, you cannot combine them. I don't see any way how you can combine them. Not sure what you were thinking of, what kind of combination you want to make, but no, I don't see it possible. Yesterday there was a bit of questions. It was in the private chat, but private DMs about Docker. Also mentioned already that there is an official Payara Micro Docker image that you can start from. It's also following best practices. So a few scenarios how you can use Docker in combination with Payara Micro. And yeah, there is, again, I have a preference, but okay, they are probably equally well. It just depends how you want to use it, and maybe some functionality is easier to do with one of those three ways. The first way is that you have your project, and in your project file, in your Maven project file, there is nothing specific around Docker. So the only thing what is there is specified is, for instance, that you have that Payara Micro starting from that official image. I need to update that to the latest version now, and I'm copying my application, which is built through Maven with the through the package phase. Gradle is also possible, of course. That I copied that to that specific directory, as I mentioned. If you build this image, then you have an image with Payara Micro and your application. When you start it up, just that image, then your application is part of that image, is ready to answer requests. That's one thing. You can here also customize options like the adlibs for that JDBC driver. You can copy that to a certain directory, change the command line paths to add that adlib, to have that property files, etc. So that you have an image which does what you need. And that's one way. Basically, using pure Docker and Docker build files and those things, not any kind of specific integration within your project or whatever. At least, as I said, there are equally well, but at least for those who are not familiar with Docker at all, so the first steps, I recommend that you just learn this kind of this way of working, because that will help you if you are going to use one of the other methods. So if you are completely new to Docker, probably this one is the most easiest one. And you also find information and documentation around how to use it. So that should get you started. Question of Oliver: if we use Docker images and REST calls, do we need to set up a Hazelcast cluster, or would the cluster be used for nodes that implement the same REST API? The idea behind this question is how the proper cluster would like in a cloud environment. So from what I understand, the question is that you want to cluster multiple instances which are running the same application, but you do not want to cluster two different type of applications. So you want to keep it for one thing. Then in the sense that do we need to set up something? No. Well, yeah, yes and no. It depends on where you're running it. For instance, if you're running with Docker Compose, for example, and you assign multiple instances to the same network, then the normal discovery of Hazelcast, because actually that's pure Hazelcast is task, then they will find each other and they will cluster. Since then your second application will be then on a second network segment, a second named network, for example, then they don't see each other, and that's probably what you want, that you don't mix data from one application to another application. For Kubernetes, there is a additional Hazelcast Kubernetes dependency modified by Payara, so that it discovers other pods which are running in the same service. Because in Docker there, the network is again different. If you ask me, the most difficult thing about all those cloud environments is the understanding how the network works. So probably if you're running in a Kubernetes, then you need to add a certain dependency. I don't think that it's included by default. You have to include it. You need to include it. So do you need to do something specific? Well, that depends on the environment where you're running. After this few Docker examples, I'm going to show Hazelcast because it was also requested. How can you run Hazelcast locally on premise, and how you do that clustering? So I'm going to show that, and there you will see that you don't need to do anything. For the cloud, that depends on the network, because there is some broadcasting between those nodes, and if network segments don't see each other, or if that is not propagated, then of course they don't see it. And it might also be necessary to give your cluster, your Hazelcast cluster, a name, so that you have different clusters so that they don't mix and match. That's also a thing that you might need to do. But again, most of those things are quietly well described on the Hazelcast documentation itself, because it's pure Hazelcast. It has nothing to do with Payara Micro. Payara Micro has it integrated, but does not do that much specific things for clustering on top of that Hazelcast, which is different for the Payara server. There are a few additional things. So this is the basic starting thing, which is easiest way to get it learning. The next step is that you are using a Maven plugin. I did not check the other one. This is the, because yesterday I got a question about about the JIB Maven plugin, which is another Java image builder, JIB. This one is using, both examples is using the Fabric 8 Maven plugin. You also have the JCube Maven plugin. So there are at least what I know, 3 different plugins that can build your image on the fly. And with on the fly means that you need to define your image, that's that Docker file that I showed here, this one, that you need to define that within the XML of your Maven plugin. Which might not be the easiest way, and especially not if you don't know what your end result needs to look like. So that's why I start with the first version. This XML does exactly the same as that other one. So I'm creating a Docker image, except for the name. I explicitly set the name and a tag here, which I don't have with the other one, but I specify a image from which I start. Not this 4. We are not 24. That's a bit too far in the future. My target directory, and so the artifact in my target directory, that means my WAR file will be copied to this directory. So that's the meaning of this little piece. And then you have the same thing. This is a alternative where I am using a Docker file itself, because sometimes this can become, okay, I had now a Docker file with only 2 lines, which was not that bad, but another extreme with what I saw with one customer is that they had a Docker file with around 150 lines, which also was a bad thing because they were doing wrong things. But anyway, if you are trying to convert that 150 lines Docker file to something like this, that will be a nightmare. So if it becomes a bit larger, then you can already specify that that a Docker file needs to be used, and then it's going to look here in that source main Docker. And then you have a special directory called Maven, which is actually the output of this assembly. Again, that can be sometimes a bit of pain to find all those things out, so what exactly the name needs to be, etc. So use it if you're familiar with it. Use it if you are comfortable with those kind of things. JCube is another one. And at least there you can also create Kubernetes, Kubernetes service definitions. So it creates YAML files, service definitions, deployment definitions, etc. But when I tried this out, it was April or something with that version 1.8, it did not work. So he created a few files. He created a few YAML files, but they were not usable. This part, which is more or less the same as the Fabric 8, because JCube is some kind of fork of Fabric 8, that still works. That was not a problem. But here, where you define those Kubernetes resources, there it failed. It did not work. I think there were valid YAML files, so I could apply them to a Kubernetes cluster, but it was not the expected results or the things that I had in mind that it was working. Again, probably due to my lack of knowledge of all those plugins. So most of the time, but that's my preference, but most of the time I either just use plain Docker files, or I'm using these kind of things with the Fabric 8 plugin. But do read about best practices, how you create your Docker, how do you need to create your Docker build file, because there are important aspects about those layering. I mentioned already before, layering is important, and so the order of things can be important. So most of the time, persons say, "Oh, I need to." For instance, I specify JVM options, so I copy my file and then I specify JVM options, and then I do some kind of execution. Okay, that's not the correct words, and they put it in that order. But that means every time you change your WAR file, also those two other layers are executed. So funny thing is, you can just define it like this, of course. You can even define, not always, but not an actual execute, but that when the command, when your container starts up, does not need to be the last one. So it can be the second last one, because this is not executed when your Docker is built, your Docker image is built. It is only executed when your image is started by the container itself. So at that point, you have already your WAR file there. So that can save you some time, maybe some half a second or what, maybe don't, but it can save you some time in creating your Docker build. So there are some important things to know around Docker. You find most of them on the internet. At least I learned from those. Any other Docker question, specific container question? I think that's now the moment, the last time that we will discuss something around it. Next thing that was requested was, how can I make use of Hazelcast in a clustered setup? And then I assumed assume Hazelcast to exchange data between different instances of your same application. And there are two options. One is just using pure Hazelcast without the additions that Payara did on top of it. Also, it's and the second thing is that you can also use what's called the JCache specification. That's a specification which is, strangely enough, not included in Jakarta EE, but it is a specification of the JCP, the Java Community Process, which is the overall arching organization which covers all the specifications from Java. But it was never included in one of the versions of Jakarta EE itself, although it was intended to be the case, but it wasn't. It never happened. But you can use that cache API and even with a specific addition of Payara. That's why I have this Payara API here. More on that in a moment. Actual example, I kept it again as simple as possible when I created it yesterday, is that you have a servlet. It works, of course, within any CDI, although there is no CDI annotation here. Every servlet is also a CDI, can be used to inject something from CDI. It's not a CDI bean itself, the servlet, but you can inject CDI beans into a servlet. So pure Hazelcast way, you can, that's something that Payara Micro does for you. You can make that Hazelcast instance injectable. You can just inject that, and for those people that know how to work with Hazelcast, you can ask them for that. Is it a map? Yeah, you can ask for a certain map. my map name, and then you can put things in that map, and then it's actually a map which is managed by Hazelcast, which means that if I put it in one instance, some value, it is immediately, okay, there is a little delay. There is, of course, a little bit latency that is also available later on after a fraction of nanoseconds, probably. It is also available in another instance of your application. If you do their get map and do a get, then you get there the same value back. So that's pure the Hazelcast way of working with it. By injecting that Hazelcast instance, there is a default configuration which serves most cases. You have the opportunity to specify a configuration file yourself when you start up with one of those command line parameters, and then you can give other config parameters, like there are some collections within Hazelcast that say I keep X amount of elements in memory, like saying I can only have, for instance, a list of 1,000 elements. If I put 1,001 element or something, then the first one element is thrown out, or the oldest element is thrown out, and those kind of things. So that is configurable by plain Hazelcast, and that you can link that configuration file link at startup, just as we did with that adlib and that system property files. The second way is using JCache. JCache, and so that's coming from that specification, that API, defines, okay, it's not entirely true, but it defines some maps, key value pairs, but of course that there is more in JCache, but let's keep it simplified here, that you define maps here. Hazelcast also implements this caching, this JCache API, so that means that actually everything that you put in here is put into Hazelcast and is then available within the entire cluster. This is the addition of Payara Micro. You see, it comes from Payara API dependency, which is an opportunity, the possibility to inject a cache as if it would be a CDI artifact, because by default, JCache was not designed with CDI in mind. So that means that you should work from, this is purely on memory from some months, some years ago. Yes, you have, yeah, from the cache manager or something, that these caches should be retrieved through the cache manager by a certain name. Payara provided you with the possibility to have the cache injected as if it would be a CDI bean, and this is then the name which is associated with this cache. And again, you can do a get value out of the cache, and you can do a put value, and since it's backed by Hazelcast in this case, it will be distributed through your cluster. So how do you start up? Let's see if there is this still running, so let's stop that. So that's it. This is instance 1, but I'm going to start, and here I'm going to start instance 2. And I prepared here a few commands. So I'm going to run my application on one port 8080. That's my instance 1. And the second one is here on port 81. Going just to wait for a second, because then you can see easier that they actually find each other and that they already communicating with each other. So now I'm starting the second one, and then you will see appear here on the instance, on the first instance, that that Hazelcast detected that there was, you see, on the same network that there was another compatible instance of Hazelcast running, and that you have now a cluster of size 2. Cluster of size 2, where you have, you cannot really see it here, but there are two the different ports assigned, and there are 2 different unique IDs to each assigned. But they are communicating now already with each other. So when I call that endpoint, that servlet here, and every time I call that servlet, I'm increasing the value in one of those caches here, that long value with 1. So I'm just adding 1 here each time. So I can do that against the first instance, and initially it was 0, so I get 0 back. Now it is increased. If I, of course, call it again on the same instance, then it will be 1. But if I call it that same application on the second instance, then I see that my value is already updated there also. And it's also propagated. So even let's just stop instance 2, sorry, and I start it again. You see that it dropped out here first. The size is now 1. It starts over again. The size is now 2. There it is. There are 2. And when I again ask instance 2, which I just launched, the counter, yeah, it's 3, of course. Question, maybe I missed it. What is the difference between MicroStream and Hazelcast? Oh, since Hazelcast is already bundled with Payara Micro, then why do I need to use another caching layer? Well, the answer is, well, if you assume that MicroStream is only a caching layer, then yes, there is no reason why you should MicroStream as a caching layer as if you have also Hazelcast with Payara Micro. But MicroStream is more than just a caching layer. It can be a pure database, which is more difficult to do with Hazelcast. And MicroStream is not designed only for Payara Micro, of course. MicroStream is designed as MicroStream and can be used in a lot of products, including Payara Micro. But it is more than just a caching solution. So in that sense, there is a difference. I hope that answers your question. Also, because for example, as an example, with Hazelcast, you cannot just put any kind of object just by default in the cache. There are also some restrictions what you can put there. There are even a little bit more restrictions on class paths and versioning, etc. So in that sense, they are not the same, but it is similar. I can agree on that. Yes. I forgot to mention, I forgot to note who requested this Hazelcast demo. So I hope it is clear how you can use Hazelcast and use it in a cluster. And as I said, depending on where you run it, you need to have some config. Here, I don't need anything because it is purely on the same network, even the same machine, but even if it's the same network segment, for example, in Docker Compose, you also don't need to do anything. Other questions around Hazelcast or Payara Micro, because we are more or less at the end of the training. I have another hands-on exercise. It's not that one. I want to GitHub. It is the example, the exercise we discussed this morning, where you have I created it already in that way, where you had, for instance, that specific database clause there. And so the idea is then that you have that you convert or you adapt it so that you can you use micro stream with or without CDI integration. That's what you want, to use that as storage and etc. I need to update it because this is no longer valid. So, but again, you can research that in the solution. I don't think that's most important for most people. They didn't came for MicroStream to this training, but for Payara Micro. If there are no more questions, then I would say thank you for the good interaction. Thank you for all your questions. They were very interesting also from my side to know what you are thinking about use cases, etc. If you need any, if you need to contact me, the contact details are on this slide. You also have there the GitHub repo by blog. So I'm working around also still not only for MicroStream, but also still around Jakarta and a MicroProfile. So you might maybe have a need for some days of help, etc. Then please feel free to contact me so that we can work out something so that your problem is solved and we are all happy. So thank you, and maybe see you, or for some of you, at a other occasion, and then we can talk again.